So let's say you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. Today I have something new. You see, I mostly cover young Earth creationism, and usually from Christians, almost always Protestant ones too. That is in large part because at one time I was a Protestant young Earth creationist, so it's personal to me. But of course, that's far from the only kind of nonsense out there. Chances are that if you're watching my channel, you already know who Roger of Mud Fossil University is. For those of you who don't know, first, Mud Fossil University is a university the same way Prager University is. That is, it isn't one in any way except in name. If you don't know his shtick, he films his computer screen, presumably because he can't figure out how screen capture software works, stabs the poor monitor with a feather, and then simply declares rocks to be actually fossilized tissue of various kinds. For example, he seems to think that granite is ground lung meat or something. Here's an example of his more typical work.
I'm saying that was real, and there's no question they're in the statues in Egypt. I found that, and that's absolutely certain. The ribs and the lungs and all that stuff are there, so that's not even a question. Now, this here, this is my evidence. You see this red, rusty looking stuff coming out of here? And this stuff is like glued on there. All right, you see this red looking stuff here? You see these dots in here? That, and I do deep research on mud fossils, and that, my friends, is two different situations going on here. That is the blood running out of the arterial. Now, you don't see the black blood because that's FeO2, and it locks itself into the veins. But the FeO3, red blood, is purged out, and here it is right here.
Of course, this statue is not a petrified real-life giant. It's the Apennine Colossus from Vaglia, Italy, which is in North Florence. It was carved by Giamologna, also known as Jean de Boulogne, a Flemish sculptor in the late 1580s. But Roger doesn't even consider the possibility that it's a statue, because he already knows that essentially all rock is petrified living things. That's just what rocks are. No, he doesn't go through the chemistry, give any reason to doubt that Giamologna carved it, or anything else like that. Just trust him, it's a real giant that someone apparently killed and posed, and then it turned into stone, somehow. But today, Roger isn't going to be talking about rocks. He's going to be talking about subatomic particles. Because you see, he's figured out that all the people who spend their whole lives studying quantum physics are badly wrong, and the standard model of particle physics is nonsense. But he's going to tell us this in the context of telling us not just how he disagrees with science, but also with Nikola Tesla, who, to be fair, was quite wrong about electrons, relativity, and particle physics generally. But we'll get into that in the video. So Roger, take it away.
Okay, my outstanding friends, this is going to be tough for some of you.
Yeah, in more than one way. First, Tesla has become something of a cult figure because he was a brilliant inventor who was unjustly overshadowed by Thomas Edison, who was less of an inventor and more of the first tech bro. As a result, there are a lot of people who think that Tesla actually secretly unlocked the secrets of the universe, but evil capitalism suppressed that because the secrets of the universe aren't profitable. In reality, those inventions of his that are not in use because they're impractical. And his work in theoretical physics was just flat out wrong in most cases. Not that he shouldn't get his due for working on things like alternating current induction motors, which in my humble opinion are way better than direct current motors, if only because they don't result in so much damn carbon dust. Have you ever tried to wash carbon dust from between your scales? I have. It's a nightmare. Anyway, back to Roger.
Everybody loves Nikola Tesla. Yes, they do. No question about it, I do too. He was a fabulous inventor, great mind, but he was not correct about the electron.
Uh-oh. I'm agreeing with Roger. Hope he says something dumb soon before reality collapses. In fact, Tesla mostly believed that electrons don't exist, and he thought that electricity was a disturbance in an ether. It's not clear to me why he thought this disturbance localized in electrical conductors, but whatever, I'm not really here to dispute or critique with a man whose theoretical work isn't really taken seriously and hasn't been for like a century. He did admit that maybe something people called an electron existed as a super rarefied plasma, which I guess he wasn't entirely wrong about. Extremely diffuse electron plasmas are a real thing, but somehow I think that while Roger is right that Tesla was wrong, he's going to correct him in the dumbest way possible, and in the process become at least as wrong as Tesla, if not more so.
And apparently, actually a friend of mine did a video about Nikola Tesla being against the electron as is portrayed in the manuals, the scientific manuals. And I am too.
Of course he is. Why would the man who thinks that rocks are the actual remains of giants and dragons, and who apparently has never heard of the concept of a statue, meaning he can't understand 5th grade earth science, be able to comprehend postgraduate level physics?
However, it does not mean that the electron is not a particle. This claim by my friend was that the electron is not a particle. Anybody that thinks is brainwashed because they just believe what they've been told. No, I don't believe anything I've ever been told.
That's true.
I do the physical, factual evidence. I don't believe Tesla. And I'm going to tell you the truth, he wasn't right. Light is particles.
Well, light is composed of photons, which are particle-like in their interactions, but propagate in a wave-like fashion. But electrons aren't light, so I don't know why we're talking about light.
And those particles are made out of electrons.
Excuse me, the did you just say?
No. Photons are chargeless force carriers with no rest mass. Electrons are charged particles of matter with a charge of -1 and a mass of about 1.9 times 10 to the negative 34th grams. Photons have integer spin, making them bosons, which means that multiple photons can occupy the exact same quantum state, and electrons have half-integer spin, making them fermions, which cannot do the same, because of the Pauli exclusion principle. Basically, it would be hard to be more wrong than to say that light, which is made of photons, is actually made of electrons. And of course, does Roger have any experiments which overturn basically everything we know about light to make it more or less the opposite of what it really is? Of course not. And here's the thing, it wouldn't be hard to do. All you need to do is shine a laser through a really strong magnetic field, which can be generated with some coiled wire and a strong direct electrical current. If the electron with its charge of -1 is what makes up the beam of light of the laser, and you can measure the strength of your magnetic field of your electromagnet, then you can calculate the expected deflection of a stream of electrons through such a field, and then measure the deflection of laser light onto a target when the magnet is on and off. If there is no measurable deflection beyond the error of your instruments, then the light is not composed of charged particles. And guess what? We already know it's not, because we can see light in areas with strong magnetic fields, like around Jupiter and the Sun. And while light is deflected due to the mass of those bodies, it is not deflected in any way that would be predicted for charged particles. Whereas on the other hand, things like electrons and alpha particles are indeed so deflected, which is why we have aurorae. If Roger were right about this, then it should get darker as you move away from the magnetic north and south pole of the Earth, and things like transformers should make all the light around them strobe, but none of that is true.
However, electrons are not just minus little tiny particles, they are dipoles.
I mean, electrons do have a dipole moment, or at least they should according to the standard model, but it's extremely small and to my knowledge has not been directly measured.
They're actually called Diracs, Dirac neutrinos.
Well, first, it's Dirac and not Dirac, but second, let's see if they're Dirac neutrinos. Well, the good news is that they are Dirac fermions, that is to say they have mass because of their interaction with the Higgs field via the standard Higgs boson. The problem, though, is that neutrinos are much less massive than electrons, and they are also not known to be Dirac fermions. Although they might be. Currently, the source of neutrino mass, which is orders of magnitude less than that of the electron, is unknown. One possibility is that they interact with the standard Higgs boson, but only do so extremely weakly. Another option is that there is a weaker unknown Higgs boson that only interacts with neutrinos. And yet another option is that there is some unknown mechanism that gives them mass. Of course, neutrinos, unlike electrons, have no electrical charge, which is rather in the name. So even though electrons are indeed elementary particles that gain their mass via the Higgs field, and thus are Dirac fermions, they are not Dirac neutrinos, because they simply aren't neutrinos.
And they have a black and a white side, and they can actually separate.
No, neither electrons nor neutrinos have sides. They don't even take up space near as anyone can tell. They're elementary particles. That means they aren't made of smaller particles, unlike, say, protons or neutrons. Even the dipole moment of an electron, which does have directionality, only gains such directionality because of the direction of motion of the electron in question relative to an observer. If you could hold an electron still, it wouldn't have a dipole moment. Nothing about what Roger is saying makes a lick of sense, and it's flatly contradicted not by just modern supercollider experiments, but like experiments people were doing in the early 20th century, and in some cases before.
And the black will congeal into a ball, and that's what black holes are. And they want the white to come to them, and the white surrounds them.
Black holes are the congealed black half of electrons, which being fundamental particles don't have halves. And here, I thought black holes were just regions of space where the gravity was so intense that the local curvature of spacetime was so strongly positive that it carved in on itself, causing space to be time-like in that it has a definite directionality, such that only motion towards the singularity is possible. But hey, what do I know? Apparently, it's the black half of an indivisible particle. So the tiny black holes that are the black half of indivisible fundamental particles wants the white half to surround them, and all of this despite the fact that neither electrons or neutrinos actually have size in the traditional sense. Fundamental particles are not objects with length, height, or width. They can't be measured with units of length. Asking how much volume a neutrino or an electron takes up can only be answered with 0, so I'm not sure what would happen if you tried to split an object of 0 volume in half. I guess since things like charge and energy are conserved in quantum mechanics, that at least hypothetically you could get 2 lower energy particles with a portion of the mass, one of which carries the original charge of the electron, but you couldn't get them to surround one another, nor would they need volume to do that. If they came back together, it would just mean they were one particle. But of course, no one has ever observed an electron split in 2 like this, or a dark black hole half-electron combined with a white glowing half-electron. This is not a thing anywhere outside of Roger's mind.
I'm going to show you my evidence. Now, he didn't have access to lasers and so forth. And I have access to everything he has, plus I'm sure other things that he didn't have access, obviously, semiconductors and CMOS and, diodes and all the new things that have been developed.
While I don't doubt that he has some semiconductors around, he does own a computer after all, and it's not at all far-fetched that he own a laser pointer, what I do think is outlandish is that he has a way to cobble these items together to perform experiments that are more revealing and have higher confidence than those being conducted at places like CERN, which has a super collider that's 27 kilometers in diameter. That's 16.8 miles for my American viewers. Put in the comments whether you think Roger, the man who thinks statues are real fossilized giants, can cobble together a more than 27 kilometer super collider with better instrumentation than CERN from laser pointers, computer components, and diodes which he has laying about the house. I feel like he doesn't, in part because the man can't figure out something as simple as screen capture software. He's literally pointing with a feather, like this is the Middle Ages or something. In fact, I actually don't think he has instrumentation that is as sophisticated as Tesla's. I bet Tesla had rudimentary ohm meters, voltmeters, Gauss meters, etc. Somehow, I don't think Roger even owns an electrical multimeter.
And I was in that realm. That's what I did. I was in the semiconductor industry. And
Okay, but was he doing theoretical work for future semiconductor technologies, where he'd have to learn new physics so that engineers can design new semiconductor applications? Was he one of those engineers who had to understand the physics well enough to design the new applications? I think that assuming this isn't simply a lie, he at best operated a machine in a factory that produced electronic components. Possibly something like the guy who runs the machine that puts the clear cap on LED light bulbs. Now, that's by no means a bad or unimportant job, but it's also not one that will give you any special understanding of quantum physics. And I'm not saying that that's the exact job Roger had, just that I'm quite confident that if he did have a job involving semiconductors, it was the kind that did not require him to understand the underlying physics.
I understand this stuff very, very well.
Boy, was I wrong.
There is particles, and they are called electrons, and I'll show them to you right now, and then we'll start from there. And I can show you these particles. They knock down houses, and they burn things, and they're particles.
Are we talking lightning here? Because that's kind of true. The actual bright channel that you see during a lightning strike is plasma, which is composed of electrons on dissociated nuclei, and the high temperature resulting from the rapid flow of large amounts of charged particles can certainly add enough thermal energy to many flammable objects that they will combust. But that lightning exists and burns things isn't really enough to demonstrate that electrons exist as actual objects. You see, Tesla thought that electromagnetic energy was a disturbance in a substance that suffused the universe called ether. The ether was what the famous Michelson-Morley experiment was trying to find. You see, ether theory says that this substance, which is what light waves wave, must be everywhere. But it presumably, being a physical material, has its own particular reference frame. There must be a way one could move through the universe if there is an ether, such that the ether is stationary compared to oneself. It also follows that since Earth orbits the Sun and rotates, it should at best only be at rest compared to the ether for a single moment of time in any given year. As a result, if you could carefully measure the speed of light and then do it in different directions at different times of year, you should be able to detect the difference in the speed of light, thereby detecting the ether wind blowing past the Earth as the Earth flies through the universe. Famously, Michelson and Morley failed to find any directional or temporal change in the speed of light. This essentially falsified the ether as the medium of electromagnetic radiation. This opened the path for things like Einstein's work on quantum physics. Fun fact, the Elder Things from H.P. Lovecraft's story At the Mountains of Madness had wings primarily not to fly through the air, but rather to fly through the ether through space.
They also have a wave, but the wave is just a function of the particle's magnetic field.
No, the particle is an excitation in the electromagnetic field. So now we get into the basics of quantum field theory. Oh joy. This is not going to be a full explanation of field theory, as I'm not really equipped to do that, nor do I think it's necessary. So a field is a mathematical space in which every point can take some kind of mathematical value. Or to put it another way, contain a mathematical object. Now, theoretically, a mathematical field could carry any mathematical object. So for instance, scalar fields carry only numbers. Vector fields, you may not be surprised to learn, carry a direction, or a vector. Quantum fields tend to carry both a magnitude and some kind of directional quality, although not always a simple vector. But that's a bit too far in the weeds for now. In quantum field theory, the typical state of any part of the field is to hover around what's called a ground state. That is, the lowest magnitude of energy the field can take. A particle in this field is an excitation in which the field takes a substantially higher in magnitude value at certain points, where this point is actually not a single location, but a distribution of probabilities. The actual behavior we observe is based on a summation of all these probabilities. An electron and its antimatter pair, the positron, are excitations of what can be thought of as an electron field. The wave-like property of electrons comes from the fact that their probabilistic properties propagate by interacting with each other in a way that mathematically can be described as a wave. But to say that the electron has a wave or has a field is a bit of a misunderstanding. Now, when an electron is in motion relative to an observer, it does produce a small magnetic field. Maybe that's what Roger is talking about. Let's find out.
Let me explain exactly. And I'm going to go one by one. There's 5 statements Tesla made about the electron and why it's not as portrayed. Okay, remember this. He experimented with these particles religiously and had a better understanding on a subject than most others. Thomson, who has been given credit to discover of the electron. Well, Tesla was working with him for years and years. Now, however,
Tesla may have been a better inventor than many of his contemporaries, and I don't care to either take that position or to argue for it. I'm just saying I have no plan to contest it. But to say that he better understood the physics behind electrical phenomena is simply false. We can actually see interactions with electrons in double-slit experiments, which are done with more than one kind of particle. Usually the experiments are done with photons and electrons, which remember aren't the same thing. So if electrons didn't exist, what is making the interference patterns in electron double-slit experiments?
he said Tesla didn't believe in the existence of the electron as pictured by today's pop science. And I also know this is absolutely wrong. Science is totally wrong about the electron. I'll show you why.
Oh wow! Hey everyone, Roger has some results of his particle physics experiments showing, with what I assume will be a confidence of at least 5 sigma, that photons are electrons, which are neutrinos, and that despite being fundamental particles, they both have volume and parts. This will be wild.
But through practical reasoning and experimentation, he believed that if it could exist at all, it does so only in a perfect vacuum. That's not true.
Roger is correct here. Electrons exist all over the place, not just in a vacuum. If you've ever been shocked by static electricity, you felt the exchange of electrons between yourself and another object. And assuming that you weren't doing this exposed to the vacuum of space, it happened in a place which was full of air.
Electrons are what everything is made of. They are literally what everything is made of. So I'm sorry, Nicola, we're not going to agree on this one.
No, they're part of what normal matter is made of. Antimatter doesn't have any electrons in it. Light doesn't either. But there are many quantum fields, like the zero-spin Higgs field, and those are neither made up of, nor do they contain electrons. Electrons are simply part of the particle zoo of the Standard Model. This zoo has the half-integer spin massive particles, such as up, down, charm, strange, top, and bottom quarks, and their antimatter reflections, the electron, muon, tau, and electron, and their neutrino counterparts, as well as the antimatter versions of those particles. It also includes the integer spin particles, such as the massless gluon and photon, the massive Z boson, W boson, and Higgs boson. The bosons are also called force carriers, because they are the way that the fundamental forces of the universe communicate with particles. Of these 30 particles, exactly one is an electron.
And then he goes on to say that it would have to be a hollow sphere or a bubble. He says a bubble can exist in such a medium as a gas or liquid because its internal pressure is not altered by deformation. Well, he's saying if you throw something against a wall, it's going to pop the bubble.
What he's saying is wrong, since no one thinks of electrons as bubbles. I'm not even sure what it would mean for one to have an internal pressure. But also, Roger is betraying a severe lack of language comprehension skill here, because this has nothing at all to do with popping bubbles by throwing them at walls as near as I can tell. I don't know where he would be getting this from.
But if, as supposed, the internal pressure of an electron is due to the repulsion of electric masses, the slightest conceivable deformation, like hitting a wall, must result in the destruction of the bubble. No, that's just not true.
Again, nothing about walls, but also this bubble analogy is nonsensical. There is no internal pressure in an electron. Electrons have mass, charge, spin, and angular momentum. None of these is well described as pressure. I know that Roger also says that this is silly, but I figure I'd talk about Tesla being wrong too, since despite the hero worship he receives in some corners of the internet, he was, in fact, not an omnipotent god of science.
Now listen to this. This is where I say we should be able to get some free energy. He understood how strongly held the electron is.
First, strongly held by what? To what? What does this mean? But second, I don't think you can understand how strongly held something is if you think that it doesn't exist. It's like saying you're planning to tie up Firelord Ozai in your basement. That plan makes no sense unless you believe there's a real Firelord Ozai who could be so restrained.
It says, just to mention another improbability, the force tending to tear an electron apart.
There is no such force, since electrons, near as we can tell, have no parts. You see, we're talking about quantum objects here, and that's a word that isn't really in most people's day-to-day vocabulary. It describes things that come in quanta. A quantum shares an etymology with words like quantized and quantity. Basically, it has to do with how much of something there is. For example, electrons all have the same electric charge with the same sign. They have a charge of negative 1.6 times 10 to the negative 19th coulombs. It's not really important to know how much that is compared to charges you're more used to, but just know that it's quite small. But it's also 3 times the smallest charge possible, and all charges are an integer multiple of that value. We tend to treat the world as if it's continuous and non-discrete in most cases. For example, intuitively, the question of what's the smallest amount of water seems to have no answer, since you could always take some, but not all, of a continuous substance away. But we happen to know that in reality, the smallest unit of water is the water molecule. You can't have less water than one molecule, and all collections of water are made of a discrete number of such molecules, which may change, but it is never split into fractional water molecules. Another example that you may be familiar with is in digital computing. Computing relies on units of data called bits, which can either have a value of 0 or 1. You can't have half a bit. A bit either exists or it doesn't. That's why in computing we transitioned from 8-bit systems to 16-bit systems to 32-bit systems to 64-bit systems. Those numbers are powers of 2, which is convenient, but in principle you could have a 9 or 10-bit system. But what you can't have is a 8.5-bit system. Half bits make no sense. What's half the value of a 2-value unit? What's half of a 0-bit? Is half of a 1-bit a half? Well, that doesn't help. Digital technology only reads zeros or ones. A half isn't a meaningful input or output. But just as bits can't simply be divided into subunits, similarly, the fundamental particles cannot be split into parts, nor do they physically contain smaller parts within them that could have some kind of pressure. We're at the bottom level of matter here. It can't get any smaller than this. It's physically impossible. Just like you can't have less data than 1 bit before you just get not having any bits at all. And just like you can't have less water than 1 molecule of water before you just have no water at all.
Is in pounds per square inch, represented by the staggering figure 256,899, followed by 21 zeros. That's how much energy it is required to tear apart the electron. That's what he says.
I'm glad that Tesla made up some number that would do an impossible thing, and that number was big. I guess if we're playing creationist bingo, you could mark off big number, although it's not big number therefore God, so maybe not. I don't know. There are no prizes, and it's your card. Mark it how you like in bird watching.
It's greater than the tension the tungsten wire can withstand, and yet it does not burst.
You can't put electrons under tension. They're not objects that can be grasped and pulled at like that. I have no clue why or how Tesla came up with any of this, but it seems he, not surprisingly, given when he lived, had no idea at even the basics of what an electron is. Now, by the time he died in the 1940s, he could have caught up to where science was at the time, and at the time it was already suspected that electrons didn't have parts that could contain pressure or be under tension. But for some reason, as far as I know, Tesla stuck to his guns on this one.
This is all an assumption he's making.
Yes, it would seem so.
Not even when it is hurled against an obstacle with a speed hundreds of thousands of times greater than that of a bullet. He said it doesn't burst. Well, it does burst, Nicola.
And here's Roger to the rescue to make sure that as wrong as Tesla was about electrons, he is going to be even more wrong. Thank you for your service, Roger. You make history's biggest scientific blunders look like a simple arithmetic error in the face of your colossal, kaiju-sized inability to comprehend basically anything, or to consider that random nonsense that comes past your ears as they're lodged with the rest of your head firmly in your own colon might not be true simply by virtue that you crapped them out. Roger is part of a small group of heroes that include people like flat earthers, vaccine deniers, geocentrists, and young earth creationists, who collectively make most people significantly above average in intellectual achievement simply by dragging the average so far down because of how far below the mass of humanity they are in that area.
It breaks in half. It was a Dirac, and it breaks into its black and white component. Let's look at that now, and then we'll go forward.
So let's look at what this means. First, it's Dirac, and all that means is that electrons interact with the Higgs field, and for this reason have mass. Now, normally only neutrinos are referred to as Dirac neutrinos, and then only hypothetically, since it's not known how they gain their small mass. Second, particles that gain mass by interaction with the Higgs field are all fundamental particles. This includes quarks, electrons, positrons, etc. This means that they fundamentally cannot split in half because they don't have parts that could separate from each other. Second, if the parts that don't exist don't interact with the Higgs field, then they need to be massless. But mass is conserved or turned into energy, so I'm really excited to hear about where this mass and or energy goes, because there's a lot of it. Well, a lot of it if we're talking on the subatomic scale.
Now remember this statement, how much energy it takes to rip these electrons apart.
Okay, I'll try to remember this nonsense statement about how much energy it would take to break apart something that doesn't even have parts in the first place.
First of all, this is literally an electron. It has a dark side and a white side. Nobody ever knew about the dark side. And that is dark matter, it's gravity, it's all the things that have been missing. Now,
none of that is true. First of all, this is not a picture of an electron, but it is a way to get across the predicted differences between neutrinos and antineutrinos of two different models of how neutrinos gain their mass and how their spin behaves. The difference is complex and involves things like the behavior of neutrino spin and their interaction with the Higgs field. But suffice it to say that if neutrinos follow the Dirac model, then neutrinos and antineutrinos are distinct particles. But if they do not and instead follow the Majorana model, then the antineutrino is more of a different way of looking at a neutrino than a distinct particle. The white and black are not parts of a neutrino, less an electron. They are describing the difference between the neutrinos and antineutrinos of these two models of neutrinos. In the Dirac model, one particle is white and the other black because they have distinctly different properties. In the Majorana model, both are a gradient of black to white because fundamentally they are the same particles and have the same properties, but it depends on how you look at them. By the way, this picture is from Fermilab, and the article is in the description.
so this is what we're talking about when we're talking about those little bar magnets.
Again, no. This is neutrinos and antineutrinos. Each neutrino doesn't have a matter end and an antimatter end under either model. I'm sorry that this picture had a weird little bit joining them. I don't know why it did, but whatever. The two balls at either end of either version of the neutrino were different particles, not parts of a neutrino, and especially not parts of an electron. It's like Roger didn't even bother to read the article this is from. He simply found a picture, it fit with some wild idea he had one night, potentially while chemically altered, and then decided that, yeah, in fact, his intuition about how particles work is way more accurate than all that pesky science being done at places like CERN or Fermilab. Those guys are just too blinded by all this rigorous statistical work, data, and experimentations to see the clear and obvious brilliance of Roger's addled delusions.
Now, how do they line up together in a photon?
They don't. Photons are not electrons or parts of electrons. They don't have mass. They don't have charge. And unlike electrons, which have half-integer spin, photons have integer spin. Exactly what spin is not really worth trying to explain at this point, but just know that subatomic particles have a property that affects how they move that is very similar in the math that describes it to the spin of classical objects, and it's called spin. Photons have a spin of 1, and one full 360-degree rotation will bring them back to the same orientation they started with. Electrons, with their half-integer spin, require 720 degrees of rotation to come back to their original state. So electrons don't have parts, and if they did, those parts wouldn't line up in photons, because electrons aren't photons. In fact, it's hard to imagine how they could be much more different.
Here's how they line up together right there.
You know, at first I thought that maybe this was some kind of image generated from a simulation of hydrogen electron orbitals, as it kind of looks like that, but I couldn't find it anywhere, including after reverse image searches. Eventually, I spent nearly an hour digging around Roger's channel for other instances of this image so I could read the text and find it that way. That didn't work. But eventually I found a video, now linked in the description, in which Roger tells us that this is actually from a picture from Rodney from Australia's cell phone. And it is what happens when he shines a laser through a venturi, which is basically just a tube that gets narrow in the middle. This is from extremely close-up camera artifacts, as the original image is basically just a lens flare. Roger took the image into an image editor, increased the size, and clearly did not do so by a factor that is a power of 2, introducing even more artifacting, and then just zoomed in on this picture until he found things that looked like what he wanted to see. That's all this is. There are no measurements, no controls, no statistical analysis. Just some guy he used to know shining a laser in a tube pointed at his phone's camera. Then sent to Roger so he can display how little he knows about rasterized images by introducing even more artifacts to an already low-quality image and then finding some weird significance in them.
That's the bar magnet, and there's the other side. They're both axial bar magnets. Up and there they are right there.
No, they're not. You can't image an electron with a phone camera and resolve some kind of image of it. Digital cameras have two kinds of resolution: an optical resolution and an image resolution. The image resolution is just how many pixels tall and wide the image they produce is. The optical resolution is how small an angular separation between two objects can be before the camera can no longer distinguish them as separate objects. So what's the optical resolution of Rod from Australia's phone camera? Well, most cameras have about 1 or 2 arcseconds per pixel of resolution. But let's be super generous and do what we did for the creationists and give Rod from Australia a free order of magnitude and go from the small end of the range. So we'll assume that his camera has the spectacular telescope-grade resolution of 0.1 arcseconds. Next, since I don't know the physical setup of the device, I'll be nice and say that the Venturi was set up 0.5 millimeters from the camera. And since I don't know the exact amount of scaling that Roger has unhelpfully added to this image, I'll estimate that to get this sort of gradient, it'll take at least 8 pixels. Note that the smaller pixel size and smaller distance between the camera and the apparatus will make this result more, not less in line with the camera picking up a tiny object like presumably electrons are. This all adds up to mean that the angular size of this object, if it were in the real world, would be about 0.8 arcseconds. And such an object, viewed at 0.5 millimeters, would have a size of 2 microns. That's the size of a large bacterium. Bacteria, as you might know, are made up of many atoms, which have many electrons, which would be hard to do if the electron were the same size as the bacterium. And remember, this is being as generous as I possibly can be to Roger, including estimating in his favor by more than an order of magnitude. Now, on top of this, we're ignoring some problems with the idea of photographing an electron. You see, electrons don't just reflect light the way a macroscopic object does. An electron absorbs and emits whole photons one at a time. You can't get an image of the shape of an electron because they don't interact with photons that way. Photons hit them, they gain energy, and then emit a photon to go to a lower energy state. But this image, if it were of an electron, would have to be formed by bouncing multiple photons from the electron or having the electron emit photons from itself in distinct parts, rather than simply from a point source, which is what they actually do. In other words, it's impossible in so many ways for Rod from Australia to have captured an electron in this photograph. As for the things on the right, it looks like it's just Roger or Rod from Australia messing with the color data to get something that looks like a heat map.
Now, the black part, as I showed you, is the dark core.
You may remember that Roger showed nothing. He claimed, and his evidence for this claim is apparently gigantic electrons photographed by Rod from Australia.
These can glow and so forth, but the other one cannot.
Here's something fun. There's this thing called conservation of energy. For something to emit light, which is what it means to glow, then the energy it must be leaving that thing. So unless it has a constant source of energy, it will fade. That's why light bulbs won't stay on without power running through them, and also why glow-in-the-dark paint fades after a while. In the case of the light bulb, the electrical current from a generator is producing the energy it needs to keep shedding photons. In the case of the glow-in-the-dark paint, light emitted onto the paint causes the electrons in the paint to become excited. Those electrons shed photons at a rate determined by a half-life depending on the chemistry of the paint in question. When in light, this will reach an equilibrium, but in the dark, the glow will slowly fade as electrons drop into lower energy states and emit photons, eventually going dark when all the stored energy is used up. So an electron can't just keep glowing as some kind of intrinsic property. Every time an electron gives off a photon, it has to lose energy. It can't just keep doing that forever.
The white glows and burns and has almost no mass whatsoever, and that has all the mass.
Once again, this picture is from Fermilab, and once again, Roger is either ignoring the text or he simply can't understand it. The article is short and linked in the description. Let's see what it has to say about electrons, and I'll quote it directly. Let's start with the easiest point-like particle we know, the electron, and assume it has zero size. Although we know that the quantum realm differs from the familiar world, in which things are measured in inches and feet, we can still get a reasonable mental image of what happens as we imagine looking at an electron with a perfect microscope. To begin with, since it has zero size, you can never actually see the electron itself. However, you notice that the electron does have an electric charge and that it sets up an electric field around it. That's the first crucial point. The second crucial point is an idea called the quantum foam, which refers to the fact that empty space isn't actually empty. Matter and antimatter particles appear and disappear with utter abandon, willfully flouting what seems like a principle of common sense. Empty space is actually pretty complicated. Now, if you combine those two ideas, that there is an electric field and that space consists of a writhing, bubbling mix of particles, then you can imagine what a point particle is like. At a large distance from the particle, its electric field is weak and doesn't much affect the quantum foam. However, as you get closer and closer to the point particle, the field becomes stronger. The stronger field affects the ephemeral virtual particles to a greater and greater degree, eventually lining up other particles with its point particle. For example, the field of a positively charged point-like particle will push away other positive particles and hold negative particles close. Thus, if you collide two point-like particles, the two particles might never actually collide. The cloud of particles surrounding them will likely interact. The point-like particle is the mathematical abstraction at the center of the particle, but the extended field, in essence, makes even a point particle not so point-like. While the quarks, leptons, and force-causing bosons of the standard model are all currently treated as point-like, there is no guarantee that this will always be true. It may be that as we probe to smaller and smaller sizes, we will eventually find that the particles we thought were point-like are actually extended particles with smaller things inside them. However, because the core particle is surrounded by this extended cloud, determining whether the core is point-like or extended is a real challenge. In summary, extended particles have a fixed size, although they may have a fuzzy edge. Point-like particles are mathematical abstractions with zero size. But even zero-sized particles have an extended effect due to the effect of the field surrounding them.
So here's what happens when light travels through. The mass particle.
And light doesn't have any rest mass, so there's no mass particle in light to speak of. But continue.
Pushes the glowy particle, which presents the field in front of it.
Again, nothing can just glow indefinitely, and further, electrons aren't two particles. They're a single point-like particle that doesn't have a defined size.
So the particle is a pair, but only this presents the field. Let me show you this actually occurring.
A physical demonstration would be wonderful, but I have a sinking feeling that we won't actually get one.
And we can actually split these apart. Normally they're attached together. That's a photon.
Okay, so wait. Are electrons photons now? So a photon is made up of a heavy part, despite photons having no mass, and also an electron, which also has mass, unlike the photon. So two massive particles, one extensive like a proton or kaon, and one point-like like an electron, add together to create a zero-mass photon that's the size of a large bacterium. I don't think that was thoroughly thought through.
Remember this, and then I'll show you the rest. That's a photon. And this is what it looks like in its energetic values.
Roger says that this is energetic values, but notice how there's no key. Those colors don't mean anything unless Roger shows his work and provides a key. He's done neither.
And you can see right there, you see those little glowy spots? I don't know if you can or not. You see them right there? That bottom one is the one that's concussing. The top one's not concussing, it's losing energy.
Okay, so for these photons to be concussing, they must be affecting something with concussion, since that's what the word means. So what's a concussion? We'll ignore the medical definition, so I'll go with a hard blow or collision. So these photons are apparently colliding. Well, that's a problem since they can't collide. Photons simply pass through each other. As a rule, bosons, that is particles with integer spin, like photons and gluons, don't really interact with each other.
And then this will glow to a point where it can't take it anymore, and it'll flip to the back, and that one will come to the front. And then that one will glow, and it'll just keep spinning that way. That's why light spins.
Right, but light doesn't spin. It's not really a thing. Now, photons have a spin, but it's not actually physical rotation. Spin in photons uses math that is very similar to angular momentum in classical objects, and in the macroscopic world we all know and love, it comes out to be polarization. That is, the light has a certain kind of directionality orthogonal to the direction of travel, and it can be filtered by the direction of spin. This is how modern 3D glasses work for 3D movies, but it's not some photons physically spinning within the photon. That would give photons an orbital angular momentum, which is another thing particles can have, but photons don't have. So again, all of this is nonsense.
It's from glowing and flipping and glowing and flipping. And I can show you that too. I have all of this very, very fully and clearly shown in all of our experiments. This is actually pictures.
I know, from Rod from Australia, and he took them with a cell phone camera, which apparently was able to pick up a photon that's 2 microns across, even though photons don't really have a size, being point particles.
Taken with smartphones, which this particular smartphone is a Galaxy S3, been years and years ago. 2014, I think they released it, 2013, something, maybe even 2012. And we've been using it. Well, Rod Warren did almost all of well, he did all of these pictures, and a couple other guys did some, but Rod did for 6 or 7 years. And it takes a long time to get it set up and get it right and get the Venturi correct and get the light going the right way. It's an arduous process, and he spent literally years doing this, and nobody would pay any attention. So
it doesn't matter how hard it is to get that particular lens flare he was looking for. That doesn't make it scientifically significant. It's kind of like an ice sculpture. I've seen a lot of people do that, and I have no clue how I could possibly do it, and it looks like a lot of work. But that doesn't mean that you're going to submit their statue to a scientific journal and expect to have uncovered something new about the physics of light. What Rod from Australia did is art, not science, and that's fine. I've seen some of his pictures, and they look like cool abstract designs. The lens flare interacts with his camera sensors in interesting patterns, and that's neat. But it doesn't mean that it's new physics. For one thing, neither he nor Roger seem to have bothered quantifying anything. I have not seen any documentation about exactly how this experiment was done apart from a crude and obviously not to scale whiteboard drawing with Roger. There is no control experiment as far as I can tell. And finally, again, I really doubt that a laser, some pipe, and a Galaxy 3S beats out the Large Hadron Collider in terms of uncovering how particle physics works. One group that is better at science than Roger is my subscribers. So subscribe now to avoid being a Roger.
He's gone dark. I can't find Rodney anymore. They threw me off of Facebook, and that's where I used to be able to work with Rodney, and I lost virtually everybody that I was working with. So,
who wants to bet he was kicked off for sharing medical and or election misinformation? I don't actually know, and I don't really care enough to look into it, but I feel like that's probably what's going on here.
Rod, if you're out there, if somebody knows Rodney Warren from Australia, I'd love to keep in contact with him. I know I sort of let him down. I couldn't get this thing seen anywhere, but
it's being seen right here, right now. It's just that there's no particular scientific significance to the lens flare in some guy's Android.
You know, and I appreciate all the work he did, but I'm still pushing it, Rod. I didn't forget you, brother, and I am never gonna, man. You showed my theory was correct, and I could have never proved this without the work that you did and all the effort that you expended, my friend, and I will never forget that.
There has been no theory articulated so far. Basically, we've heard that photons are electrons, which are Dirac neutrinos, that photons are made of black holes paired with electrons, that protons are black holes surrounded by electrons, no mention of neutrons, and no real discussion of neutrinos except to say that they are Dirac neutrinos and that electrons are in fact neutrinos. That last bit, I suspect, is the case because neutrinos come in a few flavors, electron, muon, and tau neutrino. So maybe Roger heard the phrase electron neutrino and then just thought that electrons are neutrinos? Because remember, Roger believes all passing thoughts he has about complex subjects, and never sees any reason to question his previous understanding, no matter how obviously false it may be. I also think that the reason he has decided that electrons are Dirac neutrinos is that he saw that Fermilab picture with a Dirac neutrino shown as a white and a black ball connected by some bridge. I think he saw that and decided it corresponded to his ideas about the electron, so electrons must be whatever that thing is.
Now, I'm sure he's broken down the setup and all that, and it takes literally, I don't know how many hundreds of hours it took him to get it set up in a position where we could use it. Now that all this is done, we understand now, and I understand exactly how to do it, and it is very simple. It's understanding it and developing the process that took years. But this is it. It's as simple as this. The laser shoots out the dark particles along with the white particles, the same particles here. And when they hit the Venturi, only the white ones can squirt through. They're the ones that can get glowy and little big and little. The black ones are one size fits all. They cannot get through.
Except lasers shoot out only photons, which have no mass. Further, what's the size of these black particles that are stopped by the Venturi? Photons are by all measures point-like particles, so there's no aperture too small for them to pass through, at least in theory. In practice, it's more complicated, But still, if you want to filter particles, the basic rule of thumb is that you have to make the openings in the filter smaller than the particle in question. Where do they go afterwards? Do they make the apparatus noticeably heavier? Do they produce black holes like Roger seems to think? I don't know, because this image is insufficient. Also, is he just hooking an alternating current power source straight to ground? That seems like a bad idea. But I also don't really know if that's what's going on, because this old scratched up picture with no labels doesn't really tell me much of what's going on.
This is ripping the electrons apart, exactly what Tesla said. And this energy should be off the charts.
It's ripping photons apart, which isn't something Tesla said, but whatever. But also, it's not ripping them apart, because as we've been assured, we have some directly imaged photons, disregarding how nonsensical that is, and they are not ripped apart according to Roger. So, which is it, Roger? Because it can't be both. If Rod from Australia's machine rips the dark particles from the light particles, then at the other end, there shouldn't be dark particles, or you've directly imaged photons, somehow.
And I'm trying to get this scene. Rod, sooner or later, my friend, you'll be noticed for what you did, buddy, and it was amazing.
Here's the thing. He won't be recognized for this because at best, it's some mildly interesting art using cameras. There are no measurements, no math to explain what's happening, not even any conceptual or theoretical work which isn't internally incoherent. It's a fine thing to want to overturn a reigning paradigm in science, but doing so doesn't mean coming in with some half-baked experiment. It means digging into the existing theory, doing actual experiments with measurements and statistical analysis, making testable predictions that differ from those of the dominant theory, and then actually showing that in experiment or subsequent observations, your predictions are right and those of the dominant theory are wrong. Some bloke down under pointing a laser at his camera isn't going to cut it.
Okay, this is Fermilab, and these are the two particles that they have seen. These are the smallest particles anybody has ever seen. Nobody's ever seen anything smaller, and they are what you would call elementary particles. So there's nothing smaller.
Yes, like electrons, photons, and neutrinos, they are point-like particles. The extensive particles, like kaons, neutrons, or protons, are made up of point particles connected to each other by the strong nuclear force, and therefore have a definable, if fuzzy, size. But this image isn't an example of two particular particles, but rather two different kinds of particle. I mean, Roger is showing the caption on screen. It says if you magnify an extended particle, it will look larger. A point-like particle will not change in size, but the more closely you look at it, the stronger the field surrounding it is. This is not two particular particles, but who cares? Roger has formed his first impression, and Roger's first impressions are infallible.
However, they're normally attached together. It's called a Dirac neutrino.
No, because neutrinos are elementary particles. A diagram showing the difference between normal and anti-neutrinos under two different possible models for neutrinos isn't evidence that neutrinos are composite particles that would have some measurable size.
And the Fermilab also talks about this. And they also talk about these particles being the quantum foam. Let's see, I have another Fermilab thing here. Oh, and they also say that the standard model is the most successful model ever. It is not.
What does it mean to be a successful model in science? Well, it means to make the most accurate predictions. And how do we measure accuracy? Well, by comparing the predicted values to measured values. And when they agree with a high degree of precision, that is, with lots of significant figures, then the model is very successful. Now, I'm not going to test the claim that the standard model is the most successful, because frankly, I don't care for this member measuring contest between various fields of science about whose ideas are the best supported. However, I will say that the standard model is almost incredibly accurate in its predictions. Roger, on the other hand, has yet to provide a single prediction or measurement, never mind both. So for him to poo-poo the success of the standard model is a bit rich, to say the least.
It fails miserably.
The thing is that to say that a model has failed, you have to show where and how and to what degree it's made a prediction that did not correspond to reality. Now, the standard model does fail in certain contexts. That's how physicists know that there's still more work to be done. But that it has failed in certain extreme contexts doesn't mean it's not a wildly successful theory overall. Newton's theory of gravity is very successful, and it's more than good enough to get someone to the moon. But in extreme conditions, like when neutron stars collide, or in the case of the close orbit of the Mercury to the Sun, the predictions become noticeably inaccurate. That's why relativity was accepted. It did better. But that doesn't erase the success of Newton's theory, neither in the past nor the present.
The particle is at the heart of everything is a dipole, and that's what they're made of. This is what a proton is made of. It's not one big ball like this. It's one ball like this. At a certain number, they become stable.
No, a proton is composed of two up quarks and a down quark. It's not composed of one big thing and many small things hugging it in a shell. If Roger wants to contest that, he'll have to do a lot more than just say, nuh-uh.
And I believe it's 1823 Dirac neutrinos make one proton.
That seems like an oddly specific number. Let's see where he got it from. Well, the only thing I can think of is that it's close to the ratio of mass of an electron and a proton. Each proton has a mass of 1 over 1,836.5 or so proton masses. So I think Roger just looked at how many electrons it would take to weigh as much as a proton, then just decided that those protons are literally made up of that many electrons, which he wrongly thinks are neutrinos. Because again, he just looked at a picture on the Fermilab website that he didn't understand and couldn't be bothered to try to understand, and concluded that electrons are neutrinos. And so now we're in the position where protons are somehow made of electrons, which should make them massively negatively charged when we know they're positively charged.
And then they get bigger and bigger, is in these periodic zones of stability. That's all this is.
Note, the periodic table of elements isn't arranged by stable electron numbers around protons, because that's not a thing. It's based on how many protons there are. That's what the atomic number is, and that's how the chart is arranged. Hydrogen is hydrogen because it has 1 proton. Iron is iron because it has 26 protons. This is like high school physics, and it's been known for a long time. So I doubt that Roger is just too old to have been taught the periodic table and how it works. Basically, how this works has been well known since the 1920s at the latest. So unless Roger is like 110 years old, I think this information was taught to him in school.
And these are not actual particles. Every one of these has a whole bunch of isotopes on one side or the other. And all that means is that it's missing a few of these, or it has too many. That's what an isotope is. And then it will eventually go down to stability.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul.
No, isotopes are defined by the number of neutrons in an atom, not by the number of electrons glommed onto the proton despite, not adding negative charge. And most elements have more than one stable isotope. For example, iron has 4 stable naturally occurring isotopes. And I'm also beginning to suspect that Roger thinks that the whole nucleus is a big black particle surrounded by electrons, and there's only ever one of these big black particles. So that both isotopes and atomic number are determined by how many electrons are in the nucleus, which I'll remind everyone is positively charged despite being composed mostly of electrons, according to Roger.
Stability is the zone right in the middle where it says, I don't want any to leave and I don't want any more to come. I'm stable. That's what stability is. If you have too many, they'll say, come on, get out of here, get out of here, get out of here. And all of a sudden, zip, they'll go. Or it'll say, boy, I'm telling you, I am lonely. I need another electron. Bip, they'll pop in there.
The most generous thing I can say about this idea is that Bader capture, where a nucleus absorbs an electron, turning one proton into a neutron and emitting an electron neutrino, is a thing. And so is the reverse, where a neutron turns into a proton and an electron, again emitting a neutrino in the process. But these are two among many nuclear processes, and many other forms of decay occur, such as spontaneous fission and alpha decay.
That's what happens in the nuclear realm. It is not just big balls like this.
Well, that's true. Atomic nuclei are made up of protons and neutrons, themselves made up of quarks. So Roger is correct that a marble is a poor analogy for an atomic nucleus. The problem is that in saying that, he's not disagreeing with any of science. No one who has studied nuclear physics or particle physics thinks that the nucleus is simply a single ball.
No, not at all. They are these.
Also no, for the reasons already given.
And when they smash these together, because they are these, they see all kinds of particles come out in the atom smashers.
Which seems like a problem for Roger. If smashing nuclei together gives all sorts of particles, then it seems like nuclei aren't just composed of electrons, which paradoxically are also neutrinos. That's what should come off when the atoms are smashed together, but it's not.
And we are using coherent light.
So light that is united or forming a whole. What does that even mean in the context of light? Are the various photons connected to each other somehow? If so, how? No one knows. It's just another smart-sounding word that Roger has heard before.
We are only using these. We're down in that realm. So we're only seeing the particles that exist of light, and they are particles, they make magnetic fields.
No, photons don't make magnetic fields because they are electrically neutral. If they did make magnetic fields, you could use electromagnets to bend light, but you can't. End of story. That's all there is to it.
And they actually can divide. So I'm sorry, Nicola. We got an issue here, buddy.
Nicola sounds like a new soft drink targeted at science nerds, or maybe a new brand of throat lozenges.
All right, we're going to just take a look at the particles that are the electrons, and then I'm going to explain to you how they're arranged in protons and so forth. We're going to see them all by themselves.
If protons are made of electrons, I wonder what Roger thinks quarks are. Does he just not believe in them? He seems to not believe in neutrons.
The electrons. But the electrons literally make up everything.
No.
Because they're dipoles. They have a black side and a part that's energetic.
I guess it's time to talk about what a dipole is, instead of just assuming people know. By the way, I'm really bad at figuring out what people just generally know by being functional adults who presumably made it past high school. A dipole is a system with two opposite poles some distance from each other. So for example, if you have a 9-volt battery, the two leads on it form an electric dipole. One end is positively charged and the other is negatively charged. Similarly, if you have a bar magnet, the north and south ends are two poles on a dipole. An electron is an electric monopole. It has no positively charged component, especially not one physically separated from the negatively charged component. Now, an electron that is moving relative to an observer will generate a small but real dipole magnetic field. But this is not intrinsic to the electron, but rather it is related to its velocity relative to the observers, since electrons that are moving are definitionally an electric current, and those produce magnetic fields. But on the other hand, when electrons are effectively not moving, such as when they are simply in a piece of metal under no voltage, there is no net magnetic field, as the dipole moment of any given electron is extremely weak, and the directionality of the dipole is essentially random per electron. These weak fields cannot add up to any measurable macroscopic dipole moment. However, if you apply voltage to induce current flow, then suddenly all the electrons have similar velocity, meaning that their dipole moments are mostly lined up and of significant magnitude when added together. This is how electromagnets work. And I'll remind you that if light were made up of particles that were electrically charged, like electrons, then the motion of light would also create a magnetic dipole, which would interact with the magnetic fields of anything else magnetic. And so light would be deflected by magnetic fields. But, well, it's not. Which means that the whole basis for Roger's idea is just observably wrong. And further, I don't think Roger actually knows what a dipole is, because the phrase an electron is a dipole doesn't really mean much without further explanation.
The dark side just is attractive, the other side is energetic. And when they get together in mass, the attractive side goes to the center. It's called a black hole. They're everywhere.
No. If the nucleus of atoms were black holes, then you couldn't get fission events, nor could you get any decay events that release particles, nor could you scatter nuclei against each other. All of this is contrary to basic observations that go back some century and a half or more.
Okay, I am sorry, Nicola was wrong. This is an electron.
No, it's an R828 permanent magnet, which is right on the screen. They're available for purchase online. They're actually magnetized neodymium magnets with a mostly nickel coating that has a bit of copper in it. They have a magnetic field strength of about 13,000 counts, making them pretty darn strong, given that they're only about half an inch or 1¼ centimeters tall.
Its negative charge was always considered, that's it, it's just negative. No.
Yes.
It is both negative and positive. It's what's considered a Dirac neutrino.
If an electron had both a positive and a negative charge, they would cancel out, because electrons, just like neutrinos, don't have parts. Mispronouncing the phrase Dirac neutrino neither makes electrons neutrinos, gives them parts, nor makes them electrical dipoles. Because Roger is here confusing magnetic and electrical dipoles, because he's an idiot who can't read. He can't even tell what he's looking at on screen, because he's looking at diagrams of commercially available permanent magnets, not diagrams of what an electron could be. And he's also conflating magnetic north and south with positive and negative electrical charges, which are not the same thing at all.
That will burn and stick, and it causes lightning and static and electricity. It's all it wants to do is find dark matter to attach to.
Oh, good. Now it's time to go over what dark matter is and why, no, electrons don't attach themselves to it. While an idea like dark matter was proposed all the way back in 1884 by Lord Kelvin, it was really the observations of Fritz Zwickly that got the ball rolling on dark matter. In the 1930s, he noticed that based on mass estimates for galaxies, the stars toward the outer edge of the galaxies were going too fast, and that the motion of all the stars in the galaxies were too uniform in speed. He proposed that some large portion of the mass of galaxies was invisible, and so it was called dark matter. Dark matter, whatever it is, does not interact with the electromagnetic force, making it hard to detect. It does, however, interact with the force of gravity, and probably accounts for some 85% of the gravity in the universe. Since then, other observations have tended to support the idea that most galaxies have large amounts of invisible but massive material associated with them, greatly increasing their mass. An example is that the gravitational lensing from distant galaxies is stronger than if the visible matter alone were the cause of all of it. So why does this pose a problem for electrons? Well, for an electron to interact with something, it must share some interaction with force carriers that the thing in question also interacts with. Well, by definition, dark matter does not interact with photons, which the electron does. Now, does dark matter interact with the strong or weak nuclear forces, which are the other two fundamental forces besides gravity? Well, we just don't know. But if it does, it doesn't do so by emitting anything that humans have ever learned to detect. So probably not. Since in the case of nucleons, which do interact with the force, they tend to give off things that are detectable, such as electrons and electron antineutrinos. But there is no evidence of such events from dark matter. Further, electrons don't interact with those forces either. The only force that both electrons and dark matter interact with is gravity. But gravity is so weak and electrons are so light that gravity barely affects an electron. So far from electrons sticking to dark matter, they would pass right through it unaltered. This is one of the troubles with figuring out dark matter. How do you study something that you can only infer exists through the weakest force, and therefore can only see the effects of at cosmic distances and with galaxy-sized collections of the stuff? You can't just get a jar of it on Earth, especially since dark matter cannot be contained in a jar, specifically because it doesn't interact with the electromagnetic force. Interestingly enough, neutrinos, which do not interact with the electromagnetic force, but do interact with the weak nuclear force, are a candidate for dark matter. But we still don't have any direct observations that I'm aware of weak interactions with dark matter. So that's still very much up for debate. Also, I should note, electrons do interact with the weak force.
That's its whole mission in life as an electron, is to find dark matter. Just like lightning goes bzzz, right to ground. Static, bzzz, right to ground. Electricity, bzzz, right to ground. If you grab a wire that has electricity in it, and it's not grounded, it'll go through you to get to the ground, and it will burn you up and electrocute you. That's exactly how powerful electricity is.
Yeah, but that has nothing to do with dark matter. Electrical ground is just a part of the electrical system with the lowest potential. It's not dark matter. It's not even really more than just a level of electrical energy that's used as the baseline for further measurements.
Now, when you put two together, back to back, you get a photon. Let's get into it deep.
So we're getting more specificity. Photons are two electrons back to back, which is odd since that would be a particle with a charge of -2 and a mass twice that of an electron, despite the fact that photons are observed to have no electrical charge and no mass. But further, what could possibly keep the electrons together? The electromagnetic force, which is the dominant force affecting electrons, would shove two bound electrons apart. There are instances where electrons can be coupled in superconductors, and weird things can happen there, but I don't think that's a good description for just everyday light, especially since, those coupled electrons still retain their mass and charge.
And spherical magnets, like the ones, if you can see those there, they can only be axial magnetized. There's different types of magnetism.
This axial versus diametrically magnetized magnet thing is literally just a description of how magnets are made in factories. Like permanent magnets that Roger is playing with on his desk. This has nothing to do with electrons per se. In factories, magnets are either magnetized along the axis of the cylinder they're made of, or perpendicular to said axis. In the first case, they are said to be axially magnetized, and in the second case, they are diametrically magnetized. Spherical magnets do not have a single definable axis, so you can't put anything orthogonal to it. So they are said to be axially magnetized. But electrons aren't spheres, they're point-like. Spheres must have a volume. Electrons do not.
There's actually I think about 5 different types. I can't remember now. I studied it a while back. But anyway, this is what we're dealing with when we're dealing with electrons.
No, electrons are not made of metal and cannot be purchased for a couple bucks a pop on the internet. Nor are they half an inch tall. I thought it was extreme when we thought that photons were a couple microns tall. Now we're getting half-inch tall electrons. I wonder how half-inch tall electrons can combine to become 2 microns across. Talk about bending space-time.
And photons. And the particles that Nikola Tesla said did not exist.
I really want to know when Roger manages to measure the strength of the magnetic field of a laser. It should be easy. Gauss meters and lasers are both easy to get, and I don't think Roger is destitute. Heck, he has way more viewers than me. I bet he could get his fans to get such things for him. Also, unrelated, but I do have an Amazon wishlist full of all sorts of stuff like RPG books and monitors and ramen and things.
Alright, they're talking about the smallest particles that exist. And I showed you the electron neutrino, which is the glowy little red one.
No, a neutrino can neither glow nor be red. Red is a range of wavelengths of light that is centered on about 700 nanometers. For a neutrino to glow, it would need to emit photons. But neutrinos don't interact with light, so they don't emit light. Never mind specifically red light. This also means you can't directly image a neutrino. You have to have it interact with something through the weak force, and then if that object emits something that does interact with the electromagnetic force, then that causes a little flash of light, which is how actual neutrino detectors work.
And the muon, which was the black one.
So electron neutrinos are red, even though they don't interact with the electromagnetic force, but muons, which do interact with it and have the same charge as electrons, are black, meaning that they don't interact with the electromagnetic force. I love how Roger understands everything so poorly that he's more likely to get everything exactly backwards than he is to say anything intelligible. It would be hard to be more stupid than this, and by that I don't mean unintelligent. I mean intentionally not understanding. Because the thing is, the text is right there. He could just read it. He could read that electron, muon, and tau particles are not the same particles as electron, muon, and tau neutrinos. He could read about the lack of electric charge of photons, or that electrons do have charge. He could read about the conservation of electrical charge, so that he could adjust his ideas to stop violating it. But instead, he'd rather just spout nonsense with no concern for actual data. And I shouldn't be surprised, as I'll remind you, this man thought that a statue carved in the 16th century was instead an actual fossilized giant. We're going to back the video up again to get his full statement. I just need to respond to electron neutrinos being red and muons being black, because that is a whole lot of crazy.
The electron neutrino, which is the glowy little red one, and the muon, which was the black one, are the only two things that exist in the universe that I can come up with.
So the entire universe is made of electrically negatively charged particles and non-charged particles. Does Roger have an explanation as to how it's even possible to generate positive electrical charge? I don't know. What's a tau particle? What's a tau neutrino? What are gluons or W and K bosons? Who knows? It's all muons and electron neutrinos, which is confusing because he also seems to think that electrons just are electron neutrinos, despite having a different charge and a different mass. I'm glad that Roger can't come up with anything else, but real scientists have come up with a lot more.
Everything is made of those two particles, and those two together actually make the electron. This is the electron neutrino portion, and this is the muon neutrino portion.
Wait, so are muons also their own neutrinos, despite again having different mass and charge? This is what happens when you just jump headfirst into diagrams and charts from particle physics without ever bothering to lay down the fundamentals of what terms like spin, charge, and mass are, without ever bothering to figure out what a quantum field is, and without ever concerning yourself with actually testing your hypotheses. You get someone who can't even speak coherently about his ideas. I'm really trying to figure out what the main idea even is. I know it's very concerned with electrons, and now I'm learning muons too, but since Roger doesn't know what neutrinos are, he keeps using the word in ways I can't figure out. I can't tell if he thinks that electrons and muons are neutrinos, or if they enter neutrino configurations, or if he thinks that neutrinos are a class of particles with some dipole element and that muons and electrons are a part of this class. It's impossible to say because he's so ignorant of all of this that he can't even express what his idea is in a way that would make sense to anyone who has even dipped their toes into this stuff. And I say that as someone who is basically just such a person. I have the most rudimentary knowledge of all this stuff, and I'm double checking essentially everything I put in these videos because I care about actually getting it right to the best of my ability. But then there's Roger, who just says whatever pops into his empty head, and for some reason, he gets hundreds of thousands of subscribers and tens of thousands of views for it. Being a pseudoscience pusher must be so easy.
Together, they were what's called a Dirac neutrino.
Nope, but we've already covered that ad nauseum, so I won't go over it again here.
And this is the part that burns, and this is the part that has mass.
Well, I don't know about burning per se. Both of them are charge carriers, so while muons tend to only last a few microseconds, at least hypothetically, both of them could transfer energy into flammable materials through current flow. But both of them have mass, and it's even on the chart he's using. The electron is listed as having 0.00511 gigavolts divided by the speed of light squared mass, and the muon is having 0.106 giga-electron volts divided by the speed of light squared. By the way, at these small masses, it makes more sense to express the masses in terms of their energy equivalent than to speak of them in terms of units of mass designed to measure macroscopic objects, like balls or pills. That's why giga-electron volts divided by the speed of light squared is being used to measure the mass of these particles.
Now, here's what their statement it says. It says the leptons are pictured as particles, and basically they are. At least the muon is.
No, they all are.
Now, the tau is 3,477 times as massive as the electron. And that is possible because the electron neutrino portion, I can't see any mass to it other than it just has a lot of burn. And that's what Fermilab says. I agree with what they say.
No, it's not what they say. The mass value is right there on screen, and the part he hasn't read yet says that none of the leptons show internal structure, which means that the tau isn't made up of a bunch of electrons or electron neutrinos, because then it would have internal structure.
Doesn't anyone notice this? I feel like I'm taking crazy pills!
None of these particles show internal structure.
I'm glad he's actually read that part. I was starting to think maybe he simply couldn't read. But I'm betting he's about to simply disagree and give no reason other than nuh-uh to counter the decades and decades of careful experimentation and observation that got us to the point where scientists actually know with extremely high precision what all these particles are and what their characteristics are.
Well, yes and no. Muon, no, is actually a particle. That I can show, and I can basically prove that is a particle.
I'm going to need a lot more evidence than whatever Rod from Australia captured on his cell phone before I think that Roger can show anything about muons, even if he's right about them, coincidentally.
The electron, it's a field structure. I don't know how to explain it other than that.
Yes, it is. That's what particles are in the first place.
Tau, I believe, is a couple of muons and only one electron.
Well, it's not, because that's not enough mass, and it's too much electric charge. If that were the case, the tau would be much lighter and have 3 times the electrical charge it actually has. We're at the level of you don't need any training in quantum electrodynamics to see this bullshit. You just need to be able to add and subtract numbers.
Normally you have a couple of electrons with a couple of muons. That's a photon.
Then photons would have even more mass than a tau and even more charge. But they have neither of both. It's like trying to make a table out of a musical chord. It doesn't make any sense. These aren't things that can be made up of each other.
Or you have one electron and one muon. That's an electron, really an electron.
So electrons are a muon and an electron, which is a muon and an electron, which is a muon and an electron, which is a muon and an electron, to infinity. Anyone else think that maybe electrons don't have infinite charge and mass, or is it just me?
But when you have a tau, and it's very heavy,
which it would have to be if it's made of electrons, and electrons now suddenly have infinite mass, because each electron is actually made up of an electron and a muon, and that electron is therefore also made up of an electron and a muon.
I think it has more muons, because that's where all the weight is. Almost 100% of the weight is there.
Right, but apparently if it has even one electron, it has infinite muons, and so it has infinite mass. So all anything needs is just one electron, and now it's both infinitely massive and infinitely negatively charged. And you might say I'm not being charitable, and of course that's not what Roger thinks, but the thing is, it's the actual outcome of his very unambiguous statement that electrons are made of a muon and an electron. And really, this is the guy who thinks that fossilized trees are the hair of giants, so I don't think the fact that it's absurd on the face of it is a barrier for Roger. If anything, that seems to be his general frame of mind. Just constant nonsense that wouldn't pass a basic logic test.
Less than 5% is in the electron neutrino portion.
Oh wait, so are taus made up of a muon and a bunch of electron neutrinos? Because that wouldn't give them infinite mass, but neutrinos have no way to attach themselves to a muon, since again, they don't interact with the electromagnetic force. Just trying to figure out how internally incoherent this idea is basically already a debunk. I don't even need to look up fancy physics. I can just point out that, in fact, no, electrons have finite mass and charge, so they're not an infinite number of muons.
So this, and then it goes on from here to talk all about electron positrons and how long they last and their stabilities and so forth. And then the muons, we showed a muon. The muon is the black ball.
Well, that was the claim, but muons have just as much electric charge, which to Roger apparently means burning, so that doesn't really make sense. Shouldn't they be just as burny as electrons? Except I guess they're also made up of electrons or something, or they're part of an electron? It's getting hard to keep track.
And a tau, as I said, I think is a couple of blacks and a white.
Yeah, maybe he should come up with some better phrasing for this.
And they're talking about annihilation and positron pairs and the properties of all the leptons and how long they're stable for. Because they decay almost instantaneously. These the muon, sterile muon, decays like instantaneously, and the electron shower as well. So let's look at that right now.
Imagine that, looking at the actual experimentally verified properties of things one wants to talk about. I feel like we could have started with that, but what do I know? I'm just a dinosaur. Roger here is an unparalleled genius who is leaving dunderheads like Newton, Feynman, Einstein, and Lyell in the dust.
Okay, in order to understand lepton universality, we have to understand what a lepton is. Well, they are collectively these particles.
No, they're those particles and their associated neutrinos. Definitionally, they're elementary particles of half-integer spin that do not undergo strong interactions. That is, they can't interact with a strong nuclear force.
Now, leptons and quarks are the basic building blocks of matter, they think.
And we've been given literally nothing to think that's wrong.
They are seen as the elementary particles, the most basic particles. There's 6 leptons in the present structure, the electron, muon, and tau particles, and their associated neutrinos.
Let's see if the fact that that sentence indicates that neutrinos aren't the same particles as the associated non-neutrino leptons sinks in. I'm thinking he won't figure that out, and instead is about to directly contradict what he just read from the source he himself is using.
Alright, so they have a neutrino that turns into these particles, electron, muon, and tau.
No, the associated neutrinos don't turn into their associated particles. They're associated because interactions involving those more massive particles tend to emit particular neutrinos. So, for an example, in a beta-minus decay, a neutron turns into a proton, an electron, and an anti-electron neutrino. The electron neutrino, in this case the antimatter version, is associated with a decay that produces an electron. Bizarrely, neutrinos can oscillate between different types of neutrinos, which is a big part of why they're so mysterious compared to most other elementary particles, but they can't simply change from being a neutrino into some other non-neutrino type of lepton.
Or vice versa, however you want to look at it.
Also no, and for the same basic reasons.
The different varieties of the elementary particles are commonly called flavors, and the neutrinos here are considered to have distinctly different flavors. Here they're giving them a certain mass and a certain energy and calling them an electron, a muon, and a tau.
Yes, because those particles are measured to have those masses, and what we call particles with half-integer spin, those masses, and a -1 electrical charge, is an electron, a muon, and a tau.
Lepton. Now, these leptons are pictured as particles. And I agree with that. They're all particles, yes. The tau is 3,477 times as massive as the electron. It might be possible.
Yeah, it might be possible that the insanely precise calculation and measurements that I can guarantee Roger does not understand might actually have found values for the properties of leptons. I guess that's the thing that could have happened. It's not impossible.
But none of these particles show internal structure. I can agree with that too.
I'm going to speak to Roger directly here for a moment. No, Roger, you can't. You have spent your whole goddamn video talking about how these things are made up of smaller things and how they have 2 different sides and how they spin around each other. That's literally the opposite of not having an internal structure. The entire thing up till now has been point after point attempting to show that all these leptons, which, Roger, you can't even figure out how many there are, have internal structure. Stop pissing on me and telling me it's rain. I can tell the difference.
Size may not be a meaningful word to describe them. I agree with that too, because they can glow and they don't have to have a size to have some glowy energy. I can't explain it.
I can't explain it might be the most accurate thing Roger has ever said about anything in his entire time on YouTube. Because not only can he not explain any of this, I don't even think it's explainable. I'm not sure that any of this nonsense rises to the level of coherent thought. In fact, I know some of it does not.
This is pretty interesting. 347 times as massive as the electron. Now, I don't know. I don't think they understand what an electron is, and I don't think I understand what either all of these are, because they are nothing but different. It's the same particles under different pushing and shoving energies.
I don't even know what a pushing or shoving energy would mean in this context, but I'm sure that Roger will tell us, and it will make all the sense.
And this 3477 divided by 2 is pretty damn close.
1738.5 is close to what? The ratio of the mass of a proton to an electron, which is 1836? That's the only thing I can think of, but close only counts in hand grenades and horseshoes. Does that mean Roger thinks that a tau is actually 2 protons stuck together or something? I mean, that seems dumb enough to be something he would think.
I gotta tell you, I just burst into hysterical laughter when I'm reading this.
Oh, apparently no, we don't get an explanation. Just change to a new tab, and one about a topic even more advanced than the previous ones that Roger has already failed to understand.
They're trying to explain the hints for lepton flavor universality violation. Well, they're proposing some new generations of leptoquarks. I'm going to cut down to where it just gets hysterical.
I am extremely confident that Roger understood none of that title, and that is what he finds hysterical. He seems to think that if it doesn't make sense to him, it must be absurd.
They're extending the standard model particles content by an electroquark, a muoquark, and a tau quark. We show that after taking into account other constraints, such as those originating from electroweak precision observables and delta F equals 2 processes, it is possible to provide a combined explanation for all these hints of lepton flavor universality violation. It just doesn't work.
What doesn't work? Because what we're talking about here is 3 new bosons that would interact both with quarks and leptons, which is hinted at because sometimes the way quarks decay to produce leptons doesn't perfectly line up with the standard model, which could be solved by the existence of things such as an electroquark, a muoquark, and a tau quark. But I don't think Roger even believes in quarks, and I don't think he knows what a boson is, which, to remind everyone, is a quantum particle with integer spin, and they are the particles that mediate the fundamental forces of the universe.
Moreover, we find that, listen to this, we find that the presence of the tau quark can generate a dimensional 6, whatever this thing is.
Yep, I was right. He doesn't understand it, so it must be nonsense.
Octo upper 9 operator via off-shelf photon penguin diagrams.
Pro tip, the fact that scientists sometimes give things funny names doesn't make those things fake, lies, fabrications, or useless. Another fun fact, penguin diagrams are a particular group of Feynman diagrams which describe interactions that violate charge parity symmetry, which states that you shouldn't be able to tell the difference between our universe and one where all particles are swapped for antiparticles and whose spatial coordinates are flipped. It just so happens that they vaguely look like penguins without a head, so scientists, being people who like a joke as much as the next person, decided to call them penguin diagrams. I'm sorry that the man who took seriously the idea that the Mystery Flesh Pit National Park was a real thing might find that absurd.
Okay, my outstanding friends, Roger once again, and I am calling for your help to to verify one way or the other whether this was true or not. This is supposed to be near Gumption, Texas, and it is called the Mysterious Flesh Pit. And this, I know what it is if it's real. And I've studied the mud fossils, and apparently this was a tourist attraction. And there was a big area here, which was the main bath and entrance area. And they had like tunnels running into it and so forth. I'm going to show you what I think it is biologically, because they called it a superorganism. Supposedly, this was dedicated as a national park by Jimmy Carter, and it was there, and it even shows how much they charge to get in and everything here. And this is supposedly from Mysterious Flesh Pit National Park. I don't know, and which together with the muoquark contribution further improves the global fit to B equals...
Not an equal sign there, but okay.
Whatever these little gooey things are. Oh my God. They've explained it. That really explains it.
Laughing at things you don't understand isn't an argument that those things aren't true. And I'm not going to sit here and pretend that I understood all of that. I didn't. But the difference is that I know I don't know all of what's being said. And so I know that I fundamentally cannot comment on the plausibility of it. But Roger, on the other hand, gets to just hand-wave dismiss anything that doesn't make immediate intuitive sense to him. But hey, what can I expect from the guy who thinks that Petra was carved into still wet flesh that somehow turned into sandstone?
Okay, as I have always said, all of this is nothing more than bodily tissue from just some gigantic creature. These are nothing more than muscle fibers, and these are sarcomeres, they call them. Okay, this is, I think, either part 3 or 4 of the particle physics explanation of leptons, neutrinos, subatomic particles.
First, neutrinos are leptons, but also I'm not the one editing these cuts in his video. The only thing I'm doing is cutting a bit of dead air time on either end of them. This is the actual flow of his video.
And a proton is not a big ball like that with a few leptons.
Yeah, it has no leptons, being entirely made up of quarks, namely 2 up quarks and a down quark.
It is all dipoles, all like this. Every one of these together, and in 1823, it is what they consider a stable proton.
Wrong. Just so wrong. But we've been over it. Protons aren't made up of electrons, or they'd have a negative charge. Instead, they're made up of 2 quarks, which themselves have a charge of plus 2/3, and a down quark, which has a charge of negative 1/3, giving a total charge of positive 1. Because remember, kids, electric charge is a conserved quantity. You can't simply pretend it doesn't exist. And if you add 1,800 electrons to something, you can't just ignore all the negative charge that each one adds.
At that point, it doesn't really... It's comfortable with that many particles all glued together at the same time. But each one of these is a dipole, meaning it's a bar magnet.
Again, no, the dipole moment of an electron is based entirely on relative motion. It's not just intrinsic, and if a bunch of electrons were just haphazardly somehow stuck into a ball, even though electrons don't interact with a strong nuclear force, so it's impossible anyway, the net magnetic field, even if the object were to move around, would probably be cancelled out on average. But what wouldn't happen is that you could get a positively charged proton. But also, Roger is trying to say that these electrons are surrounding an even more massive particle, which he sometimes identifies as a muon. So leaving aside here his idea of infinite muon electrons, that would give the protons the mass of 1,800 or so electrons plus a muon. But it doesn't have that mass. It only has the mass of the electrons. So what's the deal with the central thing's mass? I suspect no explanation is forthcoming.
So they are not just one big ball that they smash together and they see all bits and pieces. They're 2 big balls like this, and when they smash them, they see all these little pieces. Sometimes they see a chunk like this.
No, they don't. No one has ever seen a group of 3 electrons stuck together fly off of a proton. A proton can capture an electron and become a neutron and spit out an electron neutrino, though. But that's what gets spit out, an electron neutrino. Not 3 electrons stacked together wearing a trench coat.
There's 4 or 5 of them together. Sometimes they see one. Sometimes they actually see the bar magnet split in half, and the white goes one way and the black goes the other way. That's called electron and muon neutrinos, and they create showers.
That's going to be a big old citation needed from me. I don't think anyone has ever seen a proton bar magnet split into a shower of neutrinos.
Now, she's going to be talking about this physical anomaly vanishes. Well, no, it didn't vanish. They just figured a way of saying, oh...
By the way, the she is Dr. Sabine Hossenfelder. I figured I'd say it since apparently Roger doesn't seem to care to identify the person whose video he's about to rely on for his own.
When you read the verbiage that they put behind these explanations, and nobody in their right mind's ever going to look at it.
Yes, they will. The people who are actually trained in this field will look at it and understand it. The fact that a field is technical, and so the technical literature in that field is relatively opaque to lay people, doesn't mean that it's meaningless. It means that most people don't know how to understand it. I find paleontology papers not terribly hard to understand, but when I even describe them in any detail, most people I know can't follow it. It's not because I'm some super genius, it's because I made it my business to understand such things. Roger could make it his business to understand geology or physics, but chooses not to do either, and instead just laugh at how much he doesn't understand while also telling us that some cave is a vagina because it kind of looks like one.
That, my friends, is a vagina. And you're going to say, oh, Roger, come on. Somebody must have carved that. I said, no, don't you forget the seam we talked about. You see that? That is a vagina. And I understand, I'm pretty good with vaginas. I understand the tissue types, and I understand it pretty well. So watch this. This is Sabine Hossenfelder. This is her channel. Here she's saying here.
My apologies to Roger. He did actually say her name.
The B-meson anomaly has disappeared in recent data from the Large Hadron Collider, LHC for short. It was the particle physics anomaly which attracted the most attention in the past years, based on a slight violation of a symmetry known as Lepton universality. In a recent analysis of data from the LHCb experiment, the anomaly is gone and the results are compatible with the standard model.
Time to talk about symmetry, which I've already touched on, but let's go a bit more in depth. Let's say you met an alien electrician, and you and he, for some reason, needed to work on an electrical motor. Now, you don't know which sign convention his alien culture uses for electrical charge. Maybe it's the same as yours, but maybe it's actually the opposite, and he considers protons to be negatively charged and electrons positively charged. Or maybe he uses some other dichotomy from his culture, like high and low. Can you two still work on the same motor without being able to know each other's sign convention for electrical charge? Well, it turns out, yes. You see, positive and negative charges are just alike. They have the same strength in the proton and the electron, and they both attract the other and repel the same charge. So there's no real way to distinguish between our convention or another, but significantly, if you were transported to a world where the only difference was that the charge of the particles in that world were flipped, you'd really have no way of knowing, presuming all of your own charges were flipped too in the interest of you not dying. It would look completely identical. This is a parity or symmetry. It turns out that there are many symmetries in physics, although in some cases they are linked. For example, in some cases you may need to flip more than one thing, such as CPT symmetry, which states that there is no way to tell the difference between our universe and one in which we swap matter for antimatter, swap one spatial axis, and also swap the directionality of time as it is felt by subatomic particles. But there are less extreme and all-encompassing symmetries. One of them is lepton flavor symmetry. The symmetry states that the ratio of decay probability of different lepton flavors, that is, the different leptons such as the muon and tau, should be very close to 1. The alleged violation Dr. Hassenfelder was speaking of was a disagreement between this prediction and the results of some experiments, which showed a violation at 3.1 sigma, which is not enough to confirm a breaking of lepton flavor symmetry, but is enough to warrant further investigation.
All right, let me just mention. I looked up this article. There's nobody ever in history could possibly look at this and read it and understand even anything about it.
Once again, that something goes over Roger's head is not indication that it's incomprehensible.
So they came up with so much verbiage that by the time you're done, oh yeah, this must be right.
Or, they reported their results. Turns out physics is complicated. I don't understand all of it, but I am not so hubristic as to think that means that it's nonsense.
This anomaly had been widely reported as a possible sign of physics beyond the standard model, often by portraying it as a hint for a new force of nature. But LHCb didn't find the anomaly doesn't mean it's gone for good, because LHCb is only one of several experiments that claim to see it. So the patient isn't dead, but on life support, and the machines are beeping loudly. There are two other anomalies in particle physics which have recently attracted attention. One is the mu-G-2 measurement that slightly deviates from the theoretical prediction. It was first found in Brookhaven 20 years ago, and then confirmed at Fermilab 2 years ago. This one has never been a particularly convincing anomaly because physicists have long suspected that the reason for the discrepancy between prediction and observation isn't the theory, but rather that it's extremely hard to calculate the predicted value from the theory. The third anomaly that you may have seen in the headlines last year is a measurement of the mass of the W boson. I talked about this in more detail in an earlier video. In this case, the anomaly doesn't come from a new measurement, but from a new analysis of old data.
This is the key. I know nowhere in the world would anybody look at this and come up with a conclusion. That's why they keep changing.
Yeah, imagine that. Scientists changing their ideas when their ideas don't fit experiment. Except in these cases, we're not quite at that point. These anomalies are still being worked on, and some of them, as Dr. Hassenfelder said, may simply be due to the fact that in some areas the actual prediction of the standard model is hard to figure out. In some other areas, it may well be that there are new forces, and in others it might just be an error in measurement. But in focusing on these anomalies, one of the big things that Roger misses is how exactly most results fit the predictions of the standard model. One famous example is the prediction and subsequent discovery of the Higgs boson. Its existence was postulated as the boson that gave elementary particles like leptons their mass, and it was predicted to have a particular mass, spin, and charge, namely 126 giga-electron-volts divided by the speed of light squared, 0 spin, and 0 charged. Then it was discovered, and the predictions matched the experimental observations beautifully. That's the typical result. It's just that that's not attention-getting, so it doesn't get headlines. Instead of simply laughing at people who have dedicated their entire professional lives to understanding this stuff, and who actually are able to understand the papers that Roger says he cannot, imagine if he bothered to actually learn something.
New analysis supposedly has a very small uncertainty, which brings it in tension with other sets of data. I suspect that later this year, other groups will have a few things to criticize on that data analysis.
I got a few things to criticize right now, Sabine, and I would love to discuss it with you.
First, I don't think Roger is on a first-name basis with Dr. Hassenfelder, so perhaps he should call her by her title and surname. Second, there is as much point in Roger speaking to her about particle physics as there is in discussing wine tasting with a toddler. The toddler will at best be confused about things like bouquet, airing, sweetness versus dryness, etc. And frankly, it's not really worth explaining because the toddler isn't going to get it anytime soon, and the people who are off enjoying their wine will be better off ignoring the toddler anyway, since they won't be able to contribute meaningfully. Except this is worse, because Roger, who seems to be the intellectual equivalent of a toddler, but one who managed to acquire basic literacy skills, is also convinced that not only is what the adult's saying something that he doesn't understand, but that it actually doesn't make sense, even to them, and so they are wrong. That wine isn't dry, because it's clearly wet. If you touch it, you get wet. So he is loudly trying to get the attention of the adults to explain to them why they're so dumb to say that a particular wine is dry. Roger, if by some miracle you watch this video, there is no way in hell anyone who's actually working in the field of particle physics research would be doing anything but wasting their time in talking particle physics with a man who thinks that a statue in the catacombs of Paris is actually a real bleeding person walking through a wall.
Okay, my outstanding friends, very quick today. What do we see here? Somebody walking out of a wall. This is the catacombs. And what is this right here? Well, that looks like blood to me. What is that right there? It looks like blood to me. What is that right there? It looks like blood to me. What is this right under here? It looks like blood to me. Does it mean anything? Well, let's see. Because I have actual evidence.
Camera artifacts in Rod from Australia's cell phone pictures aren't evidence.
So I see no reason whatsoever for you not to discuss it with me. I'll be very kind and pleasant and you know, we could have a nice time talking about it.
Yeah, the guy who's been mocking everyone smarter than he is while referring to literally nothing of any scientific value, who's been ignoring every article's text that he bothered to bring up, would of course be very nice to talk to about this topic. It definitely wouldn't be an infuriating tirade of complete nonsense like infinite muon regression electrons. I'm sure that would never happen. The best Roger could hope for is the equivalent of this sadly fictional letter from the Smithsonian. Paleoanthropology Division, Smithsonian Institute, 207 Pennsylvania Avenue, Washington, D.C., 2008. Dear Sir, thank you for your latest submission to the Institute, labeled 211-D, Layer 7, next to the clothesline post, Hominid Skull. We have given this specimen a careful and detailed examination and regret to inform you that we disagree with your theory that it represents conclusive proof of the presence of early man in Charleston County 2 million years ago. Rather, it appears that what you have found is the head of a Barbie doll of the variety one of our staff who has small children believes to be the Malibu Barbie. It is evident that you have given a great deal of thought to the analysis of this specimen, and you may be quite certain that those of us who are familiar with your prior work in the field were loath to come to contradiction with your findings. However, we feel there are a number of physical attributes of the specimen which might have tipped you off to its modern origin. 1. The material is molded plastic. Ancient hominid remains are typically fossilized bone. 2. The cranial capacity of the specimen is approximately 9 cubic centimeters, well below the threshold of even the earliest identified proto-hominids. 3. The dentition pattern on the skull is more consistent with the common domesticated dog than it is with the ravenous man-eating Pliocene clams you speculate roamed the wetlands during that time. The latter finding is certainly one of the more intriguing hypotheses you have submitted in your history with this institution, but the evidence seems to weigh rather heavily against it. Without going into much detail, let us just say that A. The specimen looks like the head of a Barbie doll that a dog chewed on, and B. Clams don't have teeth. It is with feelings tinged with melancholy that we must deny your request to have the specimen carbon dated. This is partly due to the heavy load our lab must bear in its normal operation, and partly due to carbon dating's notorious inaccuracy in fossils of recent geologic record. To the best of our knowledge, no Barbie dolls were produced prior to 1956 AD, and carbon dating is likely to produce wildly inaccurate results. Sadly, we must also deny your request that we approach the National Science Foundation's Phylogeny Department with the concept of assigning your specimen the scientific name Australopithecus spiferino. Speaking personally, I, for one, fought tenaciously for the acceptance of your proposed taxonomy, but was ultimately voted down because the species name you selected was hyphenated and didn't really sound like it might be Latin. However, we gladly accept your generous donation of this fascinating specimen to the museum. While it is undoubtedly not a hominid fossil, it is nonetheless yet another riveting example of the great body of work you seem to accumulate here so effortlessly. You should know that our director has reserved a special shelf in his own office for the display of specimens you have previously submitted to the institution, and the entire staff speculates daily on what you will happen upon next in your digs at the site you have discovered in your backyard. We eagerly anticipate your trip to our nation's capital that you proposed in your last letter, and several of us are pressing the director to pay for it. We are particularly interested in hearing you expand on your theories surrounding the transpositating filifiltration of ferrous ions in a structural matrix that makes the excellent juvenile Tyrannosaurus rex femur you recently discovered take on the deceptive appearance of a rusty 9mm Sears Craftsman automotive crescent wrench. Yours in science, Harvey Rowe, Curator, Antiquities. In other words, Roger is barely worth more than gentle mocking from experts who use his inanity for their own amusement, but really, they are probably best off just ignoring him.
This is new physics. This is not something, it's just not understood. Everything is a dipole, as I will show you.
Oh, I can't wait to be shown.
Okay, Sabine talked about lepton flavor university violations. Now, what does that mean? She didn't explain it. She just said, well, they did a whole bunch of calculations, and now they figured out they were wrong, so now they're right.
No, she said the anomaly was no longer apparent in the data, and the anomaly had only been hinted at in the first place. But as I said, it was not detected with enough confidence to say that the finding had been confirmed, and it now seems like it was indeed simply a fluke. They didn't just do random math to declare themselves correct. This seems like projection. No, that's how Roger thinks it works to keep his fragile ego intact. Because I suspect, and I'm not a psychologist here, that Roger deep down knows just how stupid he is, and it eats him up inside to know that while he thinks he's the most important person in the history of science, that everyone who knows the first things about the topics he covers knows he's actually possibly one of the world's most absurd people, and that his ideas aren't worth the time it takes to hear them except to do what I'm doing, which is to mock them and also use them as a springboard to talk about things like symmetry, the particle zoo, conservation of charge, etc.
This is what I always get. Oh, well, now they figured out they were wrong, so now they're right. But then later they figured out they were right the first time, so now they're wrong. But they're really kind of right because it could be anything. And basically, that's how it works. Now, let's figure out. They're trying to stay with the standard model, the most extensively tested, confirmed since its inception in the 70s. It's not correct at all. I'll show you it's not correct.
Still waiting.
All right, they say it's the most excellent theory of history, but listen to this, what it says. The discovery of the Higgs boson in 2012, the ultimate affirmation as the prevailing theory of particle physics. Nonetheless, it is widely accepted that the standard model cannot be the fundamental theory at all energies. It's not the fundamental theory at all because it's one gigantic positive core and little tiny negatives. It doesn't work that way. They're all dipoles.
Something which no data, including these known problems with the standard model, has ever suggested.
So they admit it can't work for all energies. For instance, listen to this.
Oh, I'm listening.
It cannot account for the mass of neutrinos. They say, oh, look at all these neutrinos. We have no idea how they got their masses.
Yep, that's an open question. But let's not forget that Roger here doesn't know either, and he doesn't even know that neutrinos aren't actually their own corresponding non-neutrino leptons. He actually thinks that there is no difference between an electron and an electron neutrino, even though they have different masses and charges.
It can't account for the dominance of matter over antimatter in our universe, which could be right or could be wrong.
So it could be right that the standard model cannot account for the dominance of matter over antimatter, or it could be wrong. I mean, does Roger, who rejects the standard model entirely, think that it might actually somehow correctly account for the dominance of matter? How would that work? Why would the standard model fail us at the basics of just what an electron is, but then get something as hard to explain as the prevalence of matter over antimatter correct? Is this supposed to be a broken clock syndrome or something? Even Roger's meta-beliefs about particle physics are incoherent.
It can't exist for nothing to do with dark matter. They can't figure that out. They can't figure out gravity.
Yep, gravity being so weak it basically doesn't exist at the quantum level. So it's really hard to investigate it at that level.
It's motivated by these shortcomings. A huge number of extensions of the standard model have been proposed over the years. Well, I have an extension to change it from a big positive to little negatives to one set of particles, and everyone's the same.
Okay, but that doesn't work for so many reasons. Just the basic arithmetic doesn't work out, because it violates the conservation of energy, charge, lepton number, etc. Roger's model is crazy on the level of trying to follow a recipe by insisting that really every cup of milk is actually equal to 1 gallon of milk and 3 cups of milk, which themselves are, of course, made up of a gallon of milk and 3 cups of milk. So if you want to bake a cake, you'll need infinite milk, or it really just won't work. And if you point this out, he just says, no, it's only a cup of milk, never noticing the problem.
And when you smash it to bits, if you get down to the tiniest particle, you'll be there, which will be a positive and a negative. It's called a Dirac neutrino.
Which, for what feels like the millionth time, is not what a Dirac neutrino is, and Roger only thinks that because all he can do is look at pretty pictures, because even basic explanations for laypeople are far beyond his capacity to comprehend.
If you break that in half, you split it down to the muon and electron shower.
See what I mean? Electrons can't be made up of an electron and a muon. It's nonsensical. But I guess, what can we expect from the guy who said that meteorites contain blood?
Okay, so what would you do if you wanted to determine what's out in space? Well, we'd see what is coming to Earth from space. First of all, take a look at that stuff. And here's one of these meteorites that came through space, and they found these little pieces here. You see these? They say this is a brand new mineral, never been seen before. You see all these little dots in here? You see this black underneath this, these little flakes? Well, this is a meteorite, and it's an iron type meteorite. I have one here, iron meteorite. And it's a tiny little one. I know exactly what it is. And it is literally a body part, and so is this. And I'll show you this in the microscope. And then we are going to see the catalase reaction of the actual blood that is still in this meteorite. So motivated by these huge number of shortcomings, there's all kinds of people propose all kinds of things, but nobody's ever come up with anything solid or even been able to display it. I've done both of those things.
No, because if he had, he'd have what the actual scientists have, data. Instead, he's just got props.
So the Large Hadron Collider searches have yet to produce direct hints for the proposed particles. I show you the particles.
I'm beginning to think that he actually believes that the magnets on his desk are actual subatomic particles. I mean, remember, he, based on his own words, seems to think electrons are a half an inch tall.
Indirect searches for physics beyond the standard model have become an increasingly important avenue. Well, let's take a look at it. I showed it so many times, it's starting to get really tiring.
I'll say.
To have nobody ever even ask me a question, and I've submitted this to all these top people that are making all these claims.
Look, if you asked a baseball player why he doesn't just take more three-point shots, would it really be surprising if he didn't bother to answer? But that's the boat Roger's in with regards to people like actual theoretical physicists. He's so impossibly wrong that there's really no point in trying to correct him, unless, like me, that's just kind of your thing.
About the standard model being the most successful model in history, No, it's not. It doesn't account for anything, really. It can't even account for gravity.
No model in science accounts for everything, although that's the ultimate goal of physics, a theory for everything. But the fact that all models are incomplete as it stands now does not prevent one of them from being the most successful incomplete model among all the other incomplete models. And Roger has at no point even tried to show why the standard model has failed by using actual measurements. All we have is his word.
They say the standard model survives stringent test at Lepton University.
Universality. It's not the same word as university.
At the Atlas. So they're saying, oh, there's no problem with Lepton universality. Well, let's see what they have to say. It's short. It's only 4 minutes and 11 seconds long. So let's check this out and see if it did survive and see if I can explain why I think it didn't survive, because it can't survive because it doesn't work.
I look forward to Roger's upcoming mathematical analysis of the Atlas data.
We've just performed a brand new, very precise measurement of something called lepton flavor universality.
Keep in mind that a measurement means that there are numbers, units, and error margins. Something that, as far as I know, Roger has never given for anything he's ever claimed.
The universality of lepton couplings is the expectation that these leptons are all equally likely to be produced by a W boson, which is the particle responsible for the weak force.
I don't think Roger has ever heard of W bosons, because the only boson he's mentioned is the photon, and he somehow thinks those are made of 2 electrons, which themselves are made of an electron and a muon, which is as insane as it sounds. I'm not sure that Roger knows what a boson is, but remember, they're fundamental particles with integer spin, and they carry the energy transferred by the fundamental forces.
So this is the fundamental assumption of the Standard Model. There's nothing to say that it should be true or should not be true, and therefore we want to test this fundamental assumption as precisely as possible. So what we did the measurement of is the ratio of the W decaying to muons and to tau leptons. And this is predicted to happen at the same rate in the Standard Model, and we want to test as precisely as possible if this happens with exactly the same probability.
Imagine that. Having an idea and then actually checking to see if it's right? This is like a foreign language to people like Roger, flat earthers, and young earth creationists, all of whom are loath to actually test their ideas and then modify them when they are conclusively falsified, which they always are.
So one of the reasons for carrying out this measurement is that at the previous collider at CERN, the Large Electron-Positron Collider, which operated in the 1990s, they observed a discrepancy in this very same quantity.
Yup, but that discrepancy is relatively low confidence, and the measurements were less than precise. So it makes sense to try again and see if the discrepancy was real or not.
So the way we go about doing this analysis is that muons produce a very distinctive signature in our detector. They interact at various different points, and therefore you get little single dots, and you can join the dots and form a track.
Look at that, collecting data. Maybe Roger should try that sometime. By the way, Roger let this whole thing play, but both for time and copyright reasons, I'm not doing that. Instead, I'm cutting out bits where they say things like why this is important, or the differences between different colliders.
Tau leptons also decay to muons very often, but they do so after flying a certain distance. And therefore we can look for muons from tau leptons and muons directly from W bosons and look at the displacement from the interaction point to see if they've flown a short distance and then been produced or been produced straight away.
Wow, they're even checking for confounding variables.
So our measurement is of this ratio of the probabilities of a W decaying to a tau divided by the probability of the W decaying to a muon. And you see a value very close to 1 within our uncertainties, and our uncertainty is only 1.3%, which is about half the LEP value, which is a combination of all the 4 experiments. And therefore the Standard Model survives the stringent test of lepton universality.
Personally, I'm extremely impressed by the ingenuity of the researchers at CERN, but somehow I think that Roger will simply hand-wave it away, which is so sad. I can't state strongly enough how amazing I find the human ability to probe into parts of the universe that are so tiny and obscure that by rights, humans should never be able to know that they even exist. On the other hand, there's people like Roger or Stephen Meyer, who simply ignore any and all reality that they don't like so they can prop up some idea that they just happen to like for selfish reasons. It's just a denial of the ingenuity and the scientific capacity of humanity to act like that. The scientists who make these breakthroughs deserve better than to simply be laughed at by morons who are morons by choice.
Okay, my friends, it doesn't get any clearer than this. The Higgs particles could be the portal between us and dark sector that could hide dark matter.
Wait, Roger has no commentary? Really? He just cuts to a new thing after the video plays. I guess he just accepts all of that? Except we know he doesn't. This is just baffling. It's like Roger is the Tommy Wiseau of pseudoscience.
Hi, babe. I have something for you.
What is it?
Just a little something.
Johnny, it's beautiful. Thank you. Can I try it on now?
Sure, it's yours.
You wait right here. I'm gonna try it on right now.
Gonzalez Suarez says, certain theories predict that the dark matter interacts with normal matter by swapping Higgs bosons. If this is the case, a collision that produces Higgs could also create dark matter particles. And we did that. All right, my theory is extremely simple. They're looking for these W and Z bosons.
And now we're on to another topic. This is Matt Powell levels of whiplash here. Pro tip for any Rogers watching this, W and Z bosons aren't Higgs bosons. That's why they have different names.
Which is nothing more than the black and the white or red or green or blue particle, yes.
No! Bosons, apart from some photons, don't have a color. Color is a wavelength of light or a combination of wavelengths in the case of purple. Only photons can possibly have color. Bosons don't just give off light. Some charts of the particle zoo are color-coded for ease of comprehension, but relating that to the actual supposed color of the particles in question is like a child asking what color Sweden is, because he's seen political maps with different colors for each country, and figures that means that somehow those countries are actually that color. No adult should need this explained to them, and yet here comes Roger wondering if W bosons might be green.
That's all that exists. When you start putting these back and forth together, you make other particles.
Yes, the one thing fundamental particles are known for is being made up of smaller things, despite, that being the opposite of what being a fundamental particle is.
Alright, this is the only ones that exist, and this one here is the glowy one, and it can be any color.
Wait, I thought that electrons and muons are the only things that exist. Is Roger now saying that W bosons are electrons and Z bosons are muons? Again, they have different spin, mass, and charge, and further, they impart the weak force to leptons. They can't themselves then be the leptons they mediate the weak force for.
But the black is always black, it's always the same size, same weight, and it's heavy as hell.
Yet somehow two of them are needed to make up the zero-mass photon. But also, if this were the case, then shouldn't the W bosons have little to no mass, and the Z bosons as much mass as a muon? Instead, the W boson is about 90% the mass of the Z boson, and the Z boson has less mass than a muon. Also, remember, muons and electrons both have -1 electrical charge, and the Z boson is electrically neutral, whereas W bosons come in both positive and negative charge. Also, remember that electrical charge is a conserved number, so you can't get to zero charge or positive charge by adding negative electrons.
And here's how they work out.
Yep, I feel like these scribbles are what Roger sent all the physicists whom he complained ignored him. And let's see what's on this one, shall we? W and Z bosons are muons and electron neutrinos, which themselves apparently have color. Red, green, and blue are all the same as red. The W boson color is its impact value, or bounce, whatever that means. Apparently they also have a medium spin rate, whatever that means. Oh, but good to know that this is only the first draft. But also, let's see, we seem to have some dots showing us what things are made of in this chart of the standard model. So Z bosons, muons, and muon neutrinos are the same thing. W bosons are the same thing as electron neutrinos and the Higgs boson. Electrons are electron neutrinos plus a muon. Tau neutrinos and tau particles are both two muons. Gluons are electrons somehow. Now keep in mind that literally none of these particles actually have the characteristics that any of this would imply. I swear to Bahamut, I'm taking psychic damage from this.
The W and the Z, that's it. That's all there is.
I wonder how we get the half-integer spin particles then.
The Higgs is when they reattach together, when they are separated and come back together. Not the Higgs producing anything. The Higgs is produced when these come back together after being separated.
I guess I was wrong about what he's trying to show on that chart. But then, how does that make the Higgs different from the gluon or the electron, which according to this chart are also made up of a W boson and a Z boson? And also, notice how at no point has Roger bothered to explain or mention that W bosons come in both positive and negative flavors.
They rarely see them separated, and they rarely see them coming back together. That's why the Higgs was such a big deal. It's not. We got them coming out of our ears.
I'm sure that Roger has measurements of each of these bosons. He's just not showing them.
These two particles together make the gluon.
Which is weird because gluons have no mass and no charge, but both Z bosons and W bosons have mass, and W bosons have charge. So gluons should also have mass and charge if they're made up of W and Z bosons.
All right, the gluon is literally what we always thought was an electron.
Again weird, since electrons have mass and electrical charge, unlike gluons, and they have different spin. How is it that a W and a Z boson can combine into two radically different particles? What makes the combination have half-integer spin, negative electrical charge, and mass in some instances, but no mass, no charge, and integer spin in other circumstances?
Now, that gluon, back to back, two of them make the photon.
Shoving two gluons together means that they somehow go from carrying the force of the strong nuclear force to carrying the electromagnetic force. I'm not sure how to put it. So I guess Unexpected is the nice way to say it.
So we started out with these two. We got these to make the gluon, which is an electron. We got this, which is a photon. Now, the tau, the muon, electron is the same as the gluon, so that cancels that out. Tau and the muon and these different ups and down flavors and so forth, they're all different impacts of these two particles.
Since impact has never been defined, that means literally nothing. If this is the kind of thing he's been sending physicists, no wonder they don't respond. This is actual madness. It's like the thing you'd find in the lair of a cult worshipping the great old ones in a game of Call of Cthulhu. I'm honestly afraid for my own sanity exposing myself to this. You see, I'm a professional at looking at crazy nonsense like young Earth creationism, and I can even handle flat Earth. But this is a whole new level of dumb. This is like the Cola super deep borehole of nonsense. This is the furthest into nonsense humanity has ever managed to go, and the heat is becoming unbearable.
That's all it is. When they push together at certain points, they create certain energy level. And I show that somewhere here. Hold on. Oh, here it is.
Oh, good, more crayon scribbles with no regard for reality will definitely make Roger's case for him. Except that, no, he gives up on the scribbles and goes back to Rod from Australia's cell phone pictures of laser beams.
Alright, remember this. The white particles have virtually no weight whatsoever. The black particles are extremely heavy. And you have two black particles attached to one white here.
I'm just going to point out that all these things seem to be at nice, neat, right angles, which would correspond to the sensor grid of the camera. So we're looking at what is almost certainly camera artifacts, or potentially artifacts from compression, such as in a JPEG image. And what do you know that this image is in fact stored as a JPEG? I wonder what this could mean. Pro tip, if you want to actually carefully study an image, save it as a TIFF file. It's lossless, unlike JPEG, and has way more color depth than a PNG. Before we continue, I want to read a correction from Dr. Tapioca Weasel, who is in fact a PhD physicist. Quote, electrons do have an intrinsic dipole moment even at rest as a consequence of their spin. The magnetic moment of an electron is one Bohr magneton, and it's actually a pretty reasonable simplification to say that electrons are like little bar magnets. It's how I describe the energy levels of an atom, chance-based on an external magnetic field. When the electron's magnetic moment is aligned with the external field, the energy is lower than when the same electron's dipole is anti-aligned to that field. The interaction between the electron's magnetic moment and the magnetic moment associated with its orbital motion around the nucleus causes fine structure splitting. This is the effect responsible for tuning splitting and absorption/fluorescence line of sodium near 589 nanometers into two distinct lines very close together. This is also called LS coupling, where L is the quantum number of the orbital angular momentum, S, P, and D, atomic states you learned in chemistry for L, 0, 1, and 2 respectively, and S, this is a different S, is the spin of the electron. These two are combined in the total electronic angular momentum with quantum number J equals S plus L. Additionally, the nucleus can have a magnetic moment as a consequence of 1, the magnetic moments of the neutrons and protons, both of which have spin and magnetic moments, even the neutron because it is comprised of quarks, and 2, the orbital angular momentum of the nucleons moving about in the nucleus. The total magnetic moment of the nucleus, quantum number I, interacts with the total electronic angular momentum J to produce the hyperfine splitting on top of the fine structure splitting. Using lasers and radio frequency microwave fields to manipulate which arrangements of angular momentum within the atom is like 90% of the physics that I, that is Dr. Tapioca Weasel, do as an atomic physicist. Finally, at long last, my extremely narrow expertise lets me correct a thing that Dapper said. I have waited literal years for this. I can now die happy. End quote. Hope that clarifies from last time. Last time we were here, we heard that Roger had determined that electrons are gluons, neutrinos are the same as their non-neutrino associated leptons, and that everything else is basically made up of muons and electrons in various combinations. That, of course, is completely and obviously wrong, but that's Roger for you. I bet he's the kind that would look at the moon. Anyway, here's Roger.
That is some form of a tau neutrino, and that would be extremely heavy.
Actually, no, tau neutrinos are lighter than electrons. In fact, they're less massive than all but 2 of the leptons, the other neutrinos. They're also less massive than top quarks, strange quarks, and both W and Z bosons, which, is a problem if they're supposed to be composed of Z and W bosons.
As a particle, the 2 together and 1 white would be a very heavy particle compared to the 2 and 2. Well, when I say heavy, it would be...
Okay. Now it kind of makes sense. Roger doesn't have any idea what mass is, so of course he ignores it in all of this. Because if he doesn't understand it, then it must not be important.
Alright, these are the neutrinos. This is light coming in.
Light is made of photons, not neutrinos.
And light forms the neutrinos.
Again, no, one of the most fundamental things about neutrinos is that they do not interact with the electromagnetic force.
Now this is probably a tau neutrino.
I counter with, it's probably a compression artifact.
I'm not sure.
That's probably the least surprising thing Roger has said so far.
But then you have the straight up and down ones. There's a different form of neutrino.
And it never occurs to Roger that all of these exact 90-degree angles are a bit odd. Does he think that there's some kind of objective correct orientation for the universe? Is he claiming that neutrinos are polarized and that Rod from Australia has a lens that can filter neutrinos by polarization, but that it filters the polarization of different neutrinos differently? I'm so confused as to how he's reaching these conclusions without giving them even 10 seconds of critical thought.
What I believe is dumb.
And you have the photon.
Which again, all curiously have 90-degree rotations from each other. Almost like we're looking at something other than real objects captured by the camera, which remember, can't actually capture parts of photons, not just because photons don't have parts, but fundamentally the way the camera works is by capturing photons. And in the case of digital cameras, like in Rod from Australia's cell phone, they use the photoelectric effect to turn whole captured photons into brightness information. And hey, maybe it's time to talk about the photoelectric effect. Might as well make this more educational. The photoelectric effect is what Einstein actually got his Nobel Prize for. For centuries, the wave nature of light was well established, which is why in the early 20th century people were looking for the ether wind, assuming that if light was a wave, it needed a medium to be a wave in. As a wave, light had a wavelength and frequency and amplitude. Now amplitude is just how much energy is in a wave. And in light, it corresponds to brightness. And in visible light, both frequency and wavelength correspond to hue. Now, it was noticed that light waves could produce an electric charge when striking metal by essentially knocking electrons off the metal. But the way it did so was confusing. You see, if light is a wave, then amplitude, or brightness, should determine how much energy is transferred to the electrons, and so whether or not electrons are knocked off the metal in question should relate strongly to amplitude, and not really to wavelength at all. But that's not what was happening. With long wavelength light, you can shine the brightest beam you want and not a single electron will be freed. But the faintest imaginable short wavelength light will knock off electrons fairly easily. Einstein realized that if light came in little particle packets with an energy that corresponded to the wavelength, and the amplitude is simply the number of such packets in the beam, then this paradox is resolved. Only packets of energy that are of sufficient magnitude are enough to knock off an electron. No amount of packets that are individually too low energy to do so will ever manage to free an electron. But even one packet of energy that's big enough can do so. This neatly resolves the problem of the photoelectric effect, but also means that now light, and as we later learn, many more things, can't simply be treated as a wave or a particle. They are fundamentally both, and that realization is what kicked off the revolution that is particle physics.
Now, the reason these are showing up here and they're not like this or like this is because they're not directly in the path of the Venturi crusher.
Remember that by Venturi crusher, he just means tube with a narrow bit. Sure, would be cool to get some actual methods, like, what is the wavelength of this laser? What's the power level of it? What are the measurements of this Venturi? How far is the laser from the tube, and the camera from the tube? What camera is being used? What are its optical properties? What controls were taken, etc.? But no, we have a picture with some artifacts on it, and so we're off to the races.
But look at what happens here. Look at these up and down lines. Just this is like not letting the white get back out. It's forcing it in, creating this big black line here that forces those particles to squirt through. That's what I'm seeing.
Okay, but Roger also sees genitalia when he looks at rocks.
That, my friends, is a vagina.
I'm seeing artifacts that I have no reason to think represent anything that exists outside of the camera.
And we're seeing all kinds of different neutrino flavors. They're all over the place. So this is why this universality didn't work. They're seeing them all over the place, and they say, that's not right. If you're saying this weighs this, this, and this, and then I'm seeing them all over here, it's not working. Well, that's why.
So neutrino flavor universality has to do with which neutron flavors are produced during W boson decay. How does Roger know that the neutrinos he thinks he's seeing were produced by W boson decay? Is he under the impression that the laser shoots out W bosons? Lasers don't do that. So even if Roger were somehow correct that these camera artifacts are somehow the camera capturing images of macroscopic neutrinos, it would have nothing to do with neutrino flavor universality.
And obviously, I hope you understand, every one of these is going to have a different energy value because it's being concussed in a different way.
So the neutrinos are knocking into each other. Okay, so it would take about a light-year thick wall of lead to give a neutrino a 50% chance of being stopped. Neutrinos do not interact with each other in any way that's significant enough that just a beam of them from Rod from Australia's place would show evidence of neutrino-neutrino interactions. And of course, this is ignoring the fact that lasers just don't shoot out neutrinos. They shoot out photons.
That's why these are like an Oreo cookie, and these are straight up and down, and then these are big, huge, long lines.
Yeah, I'm sure this has nothing to do with the fact that pixel grids are laid out on a square grid with right angles. That's just a coincidence.
Setting up patterns that end up forcing these to separate and squirt that white, completely just the white. I think that is as energetic as you can possibly get.
I'm glad that Roger is energized by things squirting white stuff at him. I hope he gets as much white stuff squirted at him as he wants. Good for him.
All right, these are the 4 things physicists still wonder about the Higgs boson. I think I've shown it pretty clearly what it is.
Boy, was I wrong.
They say the collision could produce...
The feather was bad enough. The finger is so much worse.
Dark matter particles. And it does. It separates the dark matter from the white matter, really, the energetic matter. The dark matter is gravity, and it's all of the mass, almost.
Except that, remember, Roger thinks that W bosons are the so-called white matter, and have almost as much mass as the Z bosons, which he thinks are dark matter.
What I believe is dumb.
And it pushes the white particles ahead of it. So let's watch that in the house bomb, and that'll show you that the white particles are light, and they are Bernie particles.
Thank you.
And the other part of them is also light because they are one as they are light.
I think that was Deepak Chopra levels of silliness right there.
All right, you see this? It says the Higgs could be just hiding in plain sight. It says they predict the dark matter interacts with normal matter by swapping the Higgs bosons. Yes, it does.
Citation? I made it up. Good to know Roger is so confident in the standard model that he thinks its predictions about dark matter are true, but he also thinks it's completely wrong. Weird stance to take.
The collision could produce dark matter. And it does, and I'll show you that.
You heard it here first, folks. Roger from Mud Fossil U is the first human to directly detect dark matter. This should be good, and it definitely will not be scribbles on paper that make no sense.
Is the Higgs connected to dark matter or other unusual particles? Higgs is nothing more than particles coming together, and you can witness them coming together.
So not even crazy scribbles? Wow. What a letdown.
It says the Higgs boson helps explain where mass comes from. Many scientists think it should interact with dark matter. It's partially dark matter.
No, the Higgs boson is not dark matter. The Higgs boson is not a persistent thing that can exist in clouds or halos like we see with dark matter. Dark matter is almost certainly going to have to be made of fermions.
The mysterious substance seems to be connected with everyday matter. It's everywhere. This got dark matter in it. Everything has dark matter in it.
I'm going to need a citation for that, because it seems like what Roger thinks dark matter is just anything with mass. But since he also doesn't know what mass is, it makes it hard to figure out what he really means.
Because it's attached to the white matter, which is the electron, basically. And the dark matter just attaches to it. It's the other side of Dirac neutrino.
Ah yes, word salad, but with physics words, that explains it. The mystery of dark matter has been solved by just mashing up concepts in incoherent ways by the man who thinks that rocks are meat.
So anyway, they say that you could create dark matter from these energetic interactions, and we did this. They know that, they see this, they just don't understand it.
Ah, the rich irony of Roger of all people accusing actual experts of not understanding their own field. As a reminder, this is the man who couldn't tell if Mystery Flesh Pit National Park was real or not.
You see, they see any additional Higgs that we may discover would indicate that there must be new physics. And everybody knows there's new physics now. It's just that they just can't get off of the standard model. It does not work.
Except that Roger himself actually already played a video from CERN showing just how well it does work. And they actually produce data with actual measurements that can be checked by other teams using recreations of the CERN experiments. Now, we know that the standard model isn't all there is to the universe, but to say that it just doesn't work because it's incomplete is asinine.
Everything is a dipole.
It's really not, though. Like, conclusively.
And that is right there exactly how molecules are formed. And even protons. A proton has a dark core, and it has all the little electrons, the glowy parts, trying to get away from each other. And they surround the dark core. And that was what a proton is. That's why nobody's ever seen a dark core. Nobody's ever seen it. It's dark matter. Can't get to it.
I love that we're almost an hour into this video, and at no point has Roger even tried to explain the fact that positive charge exists. You'd think that if you have a new model for particle physics that will solve all the problems with the standard model, that you'd, I don't know, have a way to explain how positive charges work. It's a rather important aspect of physics. Heck, Roger's computer wouldn't work unless positively charged particles existed.
This would be a ball of white particles surrounding it. Never going to see it.
I wonder if Roger thinks that white stuff will ever be squirted at him.
We saw it because we broke everything into little bitty pieces and we could see the dark and the white parts attached. That's the difference.
Using the advanced technology of a crappy cell phone camera with a tube and a narrow bit. Much science, very convincing. Wow.
Okay, so once again, I'm sorry, Nicola was not right. The electrons have a mass.
You know, at this point, I kind of forgot that Nikola Tesla was involved in this at all.
But they contain the dark matter. They are those Dirac neutrinos. I'm sure I showed it to you. I always finish this up with the atom central house explosion here.
Ah yes, because nothing will showcase the dipole nature of electrons like shock waves in the Earth's atmosphere.
Now, watch this. This is from Atom Central. Very good people, atomcentral.com. And this is the bomb. Now, it's going off. What we are just seeing is the white particles and not the black particles.
Or, hear me out, since atomic bombs have two stages, both of them explosive, with the second stage being much more energetic, you're getting the shock wave from the first explosion, then a much more intense shock wave from the second explosion. Because while Roger might not realize this, explosions displace air, and air has mass, and so air molecules have momentum. Way more momentum than, say, a bunch of W bosons are likely to have. But it is good to know that Roger's fantasies have progressed from white stuff being squirted at him to it flooding over him in an unstoppable tide.
All right, you see that? Let's go back here and look at this in slow motion. All right, I'm going to come down here, and we're going to go playback 25%. Okay, here goes.
How to use YouTube with Roger.
I'm going to let it go. The first thing that's going to happen is the white particles hit.
That's dust.
The house just burns up. There's no mass to them.
If there were no mass involved, it probably wouldn't be blowing particulate matter off the house. But it is. Because again, we're watching air blowing against the house.
But they are energetic as hell. Now comes the black, which is all the mass. And boom, away it goes. All right, so...
Again, this is just the more intense shock wave from the actual nuclear part of the explosion.
What does that prove? It proves there's two separate entities here. One of them burns and has no mass. One of them doesn't burn and has all the mass.
No, I think it proves that, like all fluids, air can be displaced.
And here they are right here. I'm going to explain to you precisely what an atomic bomb is and why we get this exact effect.
Oh good, Roger is now smarter than the whole Manhattan Project.
No, it's just so saturated with particles around the outside of the black core. And here's the black core. Nobody sees it. Nobody knows it's there. Because it's way inside. All right, well, this would be a cap that would be over all of this. It would all be totally surrounded by white particles. When that explodes, and it's so saturated, they want to leave anyway. They concuss it this way, and then it comes out, and all the white particles goes first, as we saw, and they hit the house, and then the black particles come after. Let's watch one more time, so you can't possibly miss this. It's impossible to miss. Watch. Just keep your eye on it. I'm not going to say a word. That's pretty obvious.
I thought it was a photon. That's what it was last time.
This is an atomic bomb.
So atomic bombs work by inducing fission, and fission is the breakup of nuclei into smaller nuclei, not the breakup of photons into electrons and muons, which isn't really a thing that photons can normally do anyway. It's still amazing to me how badly Roger can understand relatively simple concepts.
And you see everything burn. Nothing moves. There's no mass to these white particles.
Then what moved all that dust? Seems like there was mass because, again, we're watching shockwaves in air, not streams of subatomic particles.
There's virtually no mass at all, and that's exactly what Fermilab says. If you look up what's the point, well, hold on a second, I think I have it on my desktop here. Yes, what's the point? There's the two particles that I'm showing. The black one is in the center. These glowy ones surround it. That's all.
Ah yes, back to Roger refusing to actually read his source. It's been a while. So I'll remind everyone that this is not describing two different fundamental particles, like Roger thinks, but describing the difference between point-like fundamental particles with spatially extensive composite particles such as protons and neutrons.
And when it explodes, all of these leave first because they're the outside, they're the crust. And that burns the house. They have no mass. Exactly what he says. Listen to this. This is Don Lincoln from Fermilab. They understand exactly what this is. Extended particles, the black ones.
Come on, man. What the extended particles are is explained in the second paragraph. I quote, "The quarks, leptons, and bosons of the Standard Model are point-like particles. Every other subatomic particle you've heard of is an extended particle. The most familiar are the protons and neutrons that make up the nucleus of an atom, but there are many others: pions, kaons, lambda particles, omegas, and lots more. The defining feature of these kinds of particles is that they have a reasonably measurable size, which happens to be about the size of a proton." So Roger is just cherry-picking here, which is deeply dishonest.
Have a fixed size. There's just one big bowling ball. Point-like particles are mathematical abstractions with zero size. Now, I can't go with zero, but I can't say they have a size to them of any magnitude.
Fun fact, a property with no magnitude has a value of 0. That's rather what 0 is. If your bank account has no magnitude of money in it, you have 0 money.
But their zero-size particles have extended effect due to the field surrounding them. Well, if something surrounds something, I would think there's something in the middle of it, but I don't know what is there.
In this case, it's the peak of the wave function that describes the probable location and velocity of a given particle if it be observed. It's not a physical thing. It's like even Roger read, a mathematical abstraction.
It's very, very small. It didn't move the house. It just burnt it.
It moved all that dust and dirt, though, and I didn't actually see any evidence of the house being burned, so that's weird.
It's just like he says, exactly what they say here.
Only if by exactly we mean not at all.
I do not discount this whatsoever. I discount the fact that the Standard Model, that is no good. It does not work at all.
I don't discount this conclusion reached on the basis of the Standard Model, but I do discount the Standard Model on which it is based. Yeah, that makes lots of sense.
Standard Model is not successful because it doesn't account for these dipole particles.
In order to say that a model must account for something, you have to show that that something actually exists to be accounted for. And remember, literally the only reason Roger has given to suggest that these dipole neutrinos exist are crappy pictures from Rod from Australia's cell phone, and him being incapable of understanding a picture from Fermilab. That's it. Unless you count him not knowing what air is when looking at atomic bomb test footage.
They see them, they just don't know what they see. Don sees them right here. You see this? He sees, that's the dipole. That is the one I'm telling you is the Dirac neutrino attached together.
The information telling us that no, that's not what's being pictured here is right on screen, and it's linked in the description. And guess what? Either Roger has a severe reading disorder, which he seems not to, since in some cases he can read words just fine, or he's actively choosing to ignore the words that are actually explaining the diagram he likes so much. I would count the latter as dishonesty. Let me know in the comments if you agree with that assessment. I'd love to have reasons to think that Roger isn't lying to me and his many fans.
We split them when we did our Venturi effect.
He really didn't, though, and he wasn't involved. Remember, it was Rod from Australia.
Now, I also agree with Fermilab about the quantum foam, which is this. It says empty space isn't empty. The space is not empty. It's loaded with this quantum foam, which is the light particles that I showed you. And they are the diracs.
So close and yet so far. The quantum foam is compared to the foam that makes up the head of a beer. The bubbles are constantly forming, collapsing, combining, and splitting. Similarly, myriad virtual particles of all kinds are appearing and disappearing in what we would normally think of as empty space, and this has measurable effects. Perhaps the most famous is the Casimir effect, in which by excluding a significant fraction of virtual particles from the space between two plates, this creates a pressure that tends to clamp the two plates shut. Virtual particles are not all just electrons, which seems to be what Roger thinks.
See, this is again my friend Don Lincoln.
I have trouble thinking that Don Lincoln thinks of Roger as a friend, although I wouldn't be too surprised if he is cordial towards Roger in correspondence. That's of course assuming that they have actually communicated. I wouldn't be at all surprised if they haven't and Roger is just inventing a friendly relationship between them.
Neutrinos, there's the dirac. That's the things I'm showing you. They're attached together where we were able to break them apart.
Except that's not what's shown, as we've already gone over. To come to that conclusion, one must completely ignore the entire text of the article.
And they talk about neutrino oscillations. I show every single thing that they have seen.
No, he's shown crappy JPEGs of a laser shining into a camera.
You see, this is why my model is correct. Listen to this. The neutrino is one of the most mysterious particles. This is right here in the standard model. The original idea of the neutrinos was formulated in response to a problem with the decay in which a neutron, which is one of these particles supposed to be neutral.
I think we finally have our first acknowledgement by Roger that neutrons even exist, which is odd considering his idea of how isotopes work, which involves electrons and not neutrons, which led me to think that he doesn't believe in neutrons, but maybe he does? I wonder where he thinks they exist and what he thinks they do.
Converts into an electron and a proton. Well, all it is it's a whole batch of electrons. So it loses one electron and then it becomes charged into a proton.
Which violates the conservation of electrical charge. I really hope Roger gets into that.
When it had an even number, it was neutral. It was a neutron. That's the only reason.
So neutrons have an even number of electrons and protons have an odd number. What, do charges multiply instead of adding? Is that the idea? Wouldn't that leave protons being negatively charged and neutrinos positively charged? I'm really trying to make sense of this, but it's just so incredibly insane. None of it makes a lick of sense.
Then it says historically, the electron in this kind of decay has been called a beta particle. The problem was that energy seemed to disappear in the reaction. No, it just gave off an electron.
For f***'s sake, Roger, the electron is the non-mysterious part that has been long accounted for. The point of the neutrino is that the energy total between the new proton and the new electron isn't as much as it was in the neutron in the first place. So that energy has to go somewhere, and it's not in the electron, so how the hell do you f*** this up so thoroughly?
Either the principle of energy conservation had gone out the window or a non-interacting particle was emitted in the decay.
Yeah, the non-interacting part is really important because neutrinos barely interact at all with anything, whereas electrons, being electrically charged, are full of interactions. Very easy to detect ones, relatively speaking.
Pauli proposed a second solution in what he called a desperate remedy. he originally called it the neutron. No, all it is if there's an uneven number, it wants one more to become even, or it wants to give one up to become even.
He said on the basis of literally nothing, and not being bothered by the fact that the emitted electron is well accounted for, and the whole point of this article is to talk about the portion of the energy which is not.
If it's an even number, it doesn't want any more, and it doesn't want to give one up because it's stable. That's what neutral means. Charged means it either wants one more or to give one up.
Then why are electrons charged all on their lonesome? Riddle me that.
And when you see the number of isotopes, I'm amazed they just don't understand this. I need to talk to Don, but he won't talk to me.
Who could have predicted that the guy Roger calls his friend Don Lincoln doesn't even talk to him? Oh wait, it was me. I predicted it. Maybe if Roger had anything that was actually worth the time of a real physicist, he would talk to him.
All right, don't forget, I'm saying it's nothing more than a big ball of electrons, which are all dipoles. They're the Dirac neutrinos, just like Don Lincoln showed.
Which is like the actual opposite of what Roger's friend, who's never talked to him, Don Lincoln, showed.
And in big balls, they become stable at certain periods. However, they have all different variations. Look at this. This is lithium. This is only number 3 here. There's hydrogen, helium, lithium. So we don't have a whole lot of particles in lithium compared to some of the big ones. Look at the type of, this is all lithium. All of those are different types of lithium. Same lithium.
Right, the same atomic number, hence the same number of protons. It has nothing to do with electrons somehow glomming onto a muon in the nucleus. In part because leptons can't be affected by gluons, and gluons are what holds the nucleus together. So we're already deep into crazy fantasy land here.
But they're only stable here and stable here. All right, at these quantities, at these masses.
Right, and the difference is the number of neutrons, which again aren't leptons because again, no strong force interactions. And for the charged ones, electromagnetic force.
Everything else is unstable. They want to give off or take on extra particles.
Right, but the very chart on screen indicates that in many cases the particles are not electrons. They're whole protons or neutrinos. So this doesn't really work with the idea that they're somehow shedding electrons, which are just gluons, even though electrons interact with each other, but not with gluons, which makes this whole thing paradoxical if electrons are gluons, as Roger thinks, since that would mean that electrons both can and cannot interact with each other.
And look at all of these different ones, and all they are is a couple of extra particles or a couple missing.
Those particles being neutrons, let's remember.
That's why lithium is so powerful. It's got a ton of isotopic type of extra electrons that you can put into it.
I don't even know what he's trying to indicate with that. I recognize all the words, and as far as I can tell, the grammar was technically correct, but no actual thought was transmitted from his mind to mine. I think that there may not have actually been something that rises to the level of thought behind that utterance.
That's why lithium is very, very reactive.
And here I thought it was because it only had one electron in its valence shell, but apparently it's because it has a lot of isotopes, which is odd. Lithium has 14 known isotopes, only 2 of which are normally encountered in everyday life, but argon, which is far less reactive, has 27, nearly twice as many. Shouldn't argon be twice as reactive then? Instead, argon basically has no chemical activity at all. Weird, it's almost like chemical activity has more to do with valence electrons than it does with how many neutrons an atom has, which, is in line with what science says.
This is the smallest particle that exists of an atom, is a hydrogen. And there's all kinds of different hydrogens. There's protium, deuterium, tritium, those are hydrogen 1, 2, and 3. And then there's some other little bits and pieces here and there. All of these are different hydrogens. It's not just one hydrogen. And they weigh differently according to the electrons.
Nope, still the neutrinos.
How many extra electrons they have.
The table literally has the neutron number listed under the N column. It's right there, on screen, right in front of his eyes.
That's all it is a combination of electrons in bigger and bigger and bigger masses, and the black goes into the center, just like it shows in the space experiments. The black really wants to go away from the white.
The space experiments, eh? I wonder what those are.
The black would love to be all by itself. Look. You see that? That's in space. That's because you don't have gravity. What is gravity?
Gravity is the warping of space-time by massive objects, which at classical scales is measurable as an attractive force between massive objects proportional to the sum of their masses and inversely proportional to the square of the distance between them.
They don't even know. This is what gravity is.
No, that's a void in dust particles suspended in a plasma in 0G by Russian cosmonauts in a low Earth orbit. Like, just check the video. It's linked in the description. And the name of it is up on Roger's screen. He could have actually paid attention.
It's dark matter.
Nope, it's not matter at all. It's literally a place where the dust isn't.
It's the other side of the Dirac.
Nope, still just a place where there's no dust.
And in space, it can separate and create these black holes. They see them all over the place. They just can't explain them. Well, this is the explanation. The dark part will in ions.
This is the first I'm hearing of this. How much would you guys bet that Roger doesn't know that an ion is just an atom with more or fewer electrons than protons, making it on net electrically charged?
And in radiation that is incomplete.
Incomplete radiation, huh? Well, that's a new one on me. I have no idea what it would mean for radiation to be incomplete.
All right, where you just have some black and you just have some white. Because we know they can separate. There's no question about that.
See, for me, knowledge is justified true belief. I think for Roger, it's just whatever stuff he made up one day and decided sounded cool.
And when they're coming off the sun and all these extremely violent sources, they're being ripped to shreds. So you got blacks and whites and black whites and black whites and white black blacks and all kinds of things going. And they're just drifting through the universe. Now, sooner or later, they're going to start to collect. These, I think, will attract to themselves.
Places where dust suspended in plasma doesn't go will attract themselves. I don't know how, and I don't feel like Roger is about to tell us, nor do I feel like he's going to tell us why the absence of dust in a plasma is a black hole, and not, the absence of dust.
The black. And all the whites want to surround them.
I love that Roger looks at a video about dust, decides that dust is really neutrinos, which are actually gluons, which are electron neutrinos, and just runs with it. Who cares what the people who did the experiment say about it? This one still kind of looks like something his deluded mind came up with one day, so that's what it must be. Wait, did I say I love that? I think I mean I hate that. Whatever verb I should have used, I definitely have a strong reaction to it.
Right, they're extremely attractive to the white.
Weird then how it's literally a place without dust. If it's so attractive to the dust, because let's remember, we're looking at dust, not electron gluon neutrinos, then why isn't the dust at that point? Why is it all around it and away from it?
And I believe they're attractive to themselves. They don't mind being on top of each other.
That's what she said.
These guys want to push each other away. That's why they will always form around the outside. And then at some certain point, they become stable. All right? And at that point, when they're stable, more will want to come in and they'll say, no, you can't come in. And they say, why not? And they say, we have enough. You have to stay. And they say, well, where do you want me to stay? Stay right there. Stay right there. That's where you are. You can stay with me and go everywhere I go, but you have to stay there.
Well, at least now we know how Roger thinks electrons ended up around nuclei. That's something.
Can I prove this? Absolutely.
Well, aside from the fact that nothing is proven in science, he's going to need a lot better evidence than lying about a Russian video and looking at blown-up JPEG sent to him by Rod from Australia.
All right, this is really cool. This is Lepton's Crazy Machines. And he's going to show how these magnets work exactly identical to the nucleus of an atom. He's going to construct this nucleus right here. Watch this. Don't forget, Lepton's Crazy Machines. Here he goes. He's taking a brass ring and he's putting a core in the center, which is the positive core.
These magnets are dipoles, and so the core isn't positive or negative, it's both north and south. But the core magnets are inserted in the opposite polarity to the magnets in the ring. This sets up a net magnetic field which is more complicated than one would get from a collection of aligned magnets, which is what will be causing the various effects. Essentially, it means that on the plane defined by the ring, there will be a radius at which ferromagnetic objects can be held at a rest relative to the whole tractor magnet because of the balancing of magnetic fields between the core magnets and the ring magnets. But this is not how electric charges work, nor are many of the things Roger thinks works this way actually even affected by the electromagnetic force in the first place.
So for us, that's the black core. All right? Can you see this? Yes, you can. That is the black core.
Which, remember, according to Roger, is a muon, which has the same electrical charge as the electrons he thinks are surrounding it, all of which are electrical monopoles, not dipoles. So all of this is a bad analogy, even if he were actually right about what protons or nuclei are made of. It's not clear if he thinks this core with an electron shell is a proton or the whole nucleus, because he is too dumb to state his claim clearly or in a way that people can understand, who know even the amount about the subject that you learn in high school.
Now, he's putting several of the other style, the other polarity around it, just exactly what I'm showing you here.
Except that all the particles Roger is talking about are electrical monopoles.
And then he's going to show you how quantum works.
Hearing the phrase, he's going to show you how quantum works, is currently making my internal organs, especially my brain, leak out of my orifices.
So here it is. Now he's taking another particle with the opposite polarity. Boom, look at that. See that? It's exactly what I'm saying. These here surround that core. And then there'll be other ones that want to get in, and they cannot get in because these will push them away. They'll come up and they'll try to get in, just like he's showing, but they'll push them away because that one there sucks it in. Now let's see if I turn it around, if it'll push it away.
Poor Roger can't even reproduce his own ideas with his own toys. Feels bad, man.
I can't get this one to push away, but they will push away when, well, actually, one magnet might, if I could roll it into the right polarity.
This must be embarrassing, even by Roger's own standards.
I could feel it pushing away, but it wants to attract, so it jumps in. But what he's doing it perfectly, watch. He can move it, it'll stay right in between those two little loops of, what's going on here is that has a magnetic field around it. This one has a magnetic field around it. It's hugged in between the two magnetic fields.
Wow, Roger actually got something right here. That is what's happening. He just hasn't demonstrated that it will work with electric dipoles. Or, that anything he's talking about is actually an electric dipole, especially since we already know they're electric monopoles.
It wants to get as close as it can. So there's really a magnetic field here and one right here. And that one's right in between. And it's jiggling itself right in there. And it's going to stay exactly in that location. And then there'll be another one that'll go right in between these two. And another one over here, and another one over here. And he shows all that stuff in this video. But he's going to move it around. It stays very tightly secure. Now, here's what he's doing. He's showing it bouncing. All right? It'll stay with it and it'll bounce. Basically, that's heat.
Wow, where was this level of analogy throughout the rest of the video? Setting aside the problem that electrons and protons aren't electric dipoles, that being heat actually tracks really well with his analogy. Roger should do more of this. It almost makes sense.
But in addition to that, the only reason it bounces is because there's somebody trying to take its place. So you're feeding more electrons in. That's what heat is when you force electrons in, trying to push that guy out of the way. Say, oh, get away from me. You get away from me. And they slap each other a few times and it gets hot.
God damn it. We were so close to making sense and then he just threw it all away. Heat is just a measure of how much kinetic energy is in the particles that make up a system. It's not caused by an inrush of electrons onto a nucleus, although electrical currents certainly do lose energy to heat. But many other things can cause heat too, such as the capture of photons.
Right, and that's what heat is right there. Now, when it flies off, it's light, or it's electricity.
Apparently, Roger hasn't noticed that light and electricity aren't the same thing. I'm not sure how he's managed to become an adult in the modern world without noticing this, but there it is. I wonder if he thinks that bare conductors always glow. I wish they did, because I'd have been shocked fewer times if all I had to do to tell if a conductor were dead was to simply see if it were glowing.
Okay, that would be basically electricity. All right, now static. Light is when you have a couple of those electrons together, and it's being spit out from an energetic source.
That would be an energetic source, but for the millionth time, photons don't have mass or charge, and electrons do. So no.
All right, light is always from an energetic source.
I mean, yeah, light is energy, so it has to come from something with energy, I guess.
Okay, I guess I'm going to leave it at this. I think I've shown enough to support the things I'm saying.
I think he does think that. Funny how no one who actually knows this field agrees.
And I think we can get free energy right there if what they're saying about the increased value of the energy is. I don't see where we can miss. We need help, and I cannot support it. No, I can't do it.
You know, Roger, when you say you can't get free energy by shooting a laser at a tube with a narrow bit, I believe you. Since no one can, because free energy is impossible. No matter how many JPEGs you look at. After this, he gives his email and asks people to contact him. I'm not including it because I don't actually think anyone in my audience should contact him via email. If you really need to, leave a polite but accurate comment on his YouTube videos. I don't see any reason to flood his inbox with emails that he won't read because it seems like he ignores anything that doesn't agree with him.
And that's just what happens in zero gravity when you have charged particles. And there's going to be nothing but charged particles in space.
Oh, so now he does know that it was a zero-G experiment. I don't even know how to parse this anymore.
They're going to be all over the place. Every single different type of lepton.
Half of which aren't charged, remember?
Baryon, hadron, neutrino.
Hadrons are those particles composed of quarks. Baryons are those with an odd number of valence quarks with a minimum of 3. None of this factors into Roger's ideas because he doesn't seem to think quarks even exist. So I have no idea how he would define such particles.
Gluon, quark, fermion.
Gluons are the force carrier for the strong force, which Roger thinks are just electrons. Even though gluons have no charge or mass, unlike electrons, and have integer spin, while electrons, being fermions, have half-integer spin. Which, by the way, is the definition of a fermion? Another on the list of words that Roger doesn't understand, but has heard and is now listing off.
Bosonic.
Bosons are the fundamental particles with integer spin, like gluons, photons, etc.
Anything you want, you're going to have them out there. And you're going to end up with them. Black ones connecting to each other and white ones surround them. It's just happening. And there's a whole new article that just came out today about black holes. NASA had a black hole in space.
NASA had a black hole in space. What, did they lose it? Did it escape the clutches of the evil NASA scientists?
Somewhere. Whatever it is. I got so much of this stuff.
Look at all those tabs. He must be doing some very high IQ research.
What do we got going here? I think this might be a... Oh, neutron stars.
Which are not black holes. So this is definitely not what he was looking for. Unless he just doesn't know the difference between neutron stars and black holes, which is entirely possible.
This is very simple to understand. A neutron star just means that all of the white particles that were on the outside have gotten scrubbed away, and all you have is dark matter left.
If neutron stars are made of dark matter, then why do they emit light? That's like the one big thing that dark matter doesn't do. That's the whole reason it's called dark matter.
And it collapses into the dark matter, and then that's all that's left. That's what a neutron star is.
And that's where the video just ends. Rather anticlimactic, but boy was it a wild ride. This has got to be the most brain-dead thing I've ever covered. Here, I thought this would be a nice break from young Earth creationism to talk about a fresh kind of pseudoscientific woo, and after this, I'm eager to get back to Genesis apologetics and friends. Oh well, if you liked this video, hit the like button and tell me what you liked in the comments. If you didn't like it, hit the dislike button and tell me why not in the comments. Either way, I hope you subscribe and use the bell icon to turn on all notifications so you're always alerted when I have new content. I'm the Dapper Dinosaur. Thanks for watching, but before you go, I just want to say a special thank you to my channel members and my patrons, especially those pledging $20 or above. Bob Knob, Work in Progress, Benthoven, Tapioca Weasel, Denny5252, Ian Chen, Landon Knoll, Mabbity Babbity, San, Sphincter of Doom, The Venerable Bede, Elleran Teller, Dr. Tapioca Weasel, and Pat L. Dennis. As you probably know, YouTube is a very volatile platform, and from month to month my income on the channel can swing wildly. But the people you see on screen are directly supporting so that I don't have to worry too much about that, and the channel can keep going as it is, and perhaps even improving. If you'd like to join this team, there are links below to join the channel or in the description to join the Patreon. The Patreon starts as low as $1 a month, and the channel memberships start as low as $1.99 a month. On Patreon, you can even get a discount for pledging annually. If you do decide to pledge, you'll get access to an exclusive Discord server just for channel supporters, as well as early access to all of my pre-recorded videos, often up to 2 months in advance. Higher tiers will unlock even better perks. Now, if an annual or monthly pledge isn't right for you, but you still want to support the channel, there is a merch store down in the description, as well as an Amazon wishlist, just for me. And if financial support isn't something you can or want to do, then if you still want to help out the channel, please just like and share these videos and make sure you comment on them. It really helps the channel out. Thanks again for watching.